So we are moving into the last part of this first unit, and that is called the vectors. So do you know about the vectors? Have you heard about that term? Vectors? Not really? Okay. This is the new tune that you're gonna get. Yeah, there will be empty page in the middle to write some notes in case, right? So if that the vector is this guy, do you know this guy? His name also said to be the vector, right? From here onwards, every tune that you're gonna receive until the last one, there will be a cover story. For every tune that will be mostly printed on the very back, right? You can later on read it or go home. Every tune has a certain specific cover story. Okay, and the front page as well. I think you know these guys, right? These are the minions and the groove with the three girls, right? Okay, so first we'll deal with the vectors, and at the very end, let me teach you about the cover story too. Uh, okay, vectors. So, what are vectors? Well, if it rings a bell, there are two physical quantities that we can consider. I mean, apart from the fundamental and the derived ones, which we have learned for the very first day, we can classify every measuring thing to be a scalar or a vector. So what's the difference between the scalar and the vector? Yes. So let's say I'm measuring the length of this table right here. Right? I just have a ruler and put it from the very end and gonna keep it on the other end and take the length measurement. And I'm gonna say it, okay, this is to be maybe 2 meters. Right? Should I need to say it like 2 meters to the left side or 2 meters to the north? No, right? It's just taking the length measurement, and in that case you are not saying the direction, only we are taking the magnitude. Let's say maybe one of your friends, um, maybe like once you're chatting, he or she asks, Machan, what's the time? So just see the watch. Okay, so it's 5 to the 10 to the south. Do you say like that? No, right? We just say the magnitude without saying the direction. So the physical quantities or physical parameters that are only having the magnitude, we say them to be scalars. You have learned this one for the O-levels. And when it comes to the vectors, we should say both magnitude and the direction, right? So the best example is going to be, let's say, we'll take it from the longest route to from here. I think you are the, no, Shantipur, right? You are the, I think, yeah, okay. I think apart from you all guys, you are the one being the lengthiest distance from here, Bandar, to your home, right? Let's say uh, this is your home at the very topmost village in the entire Sri Lanka, right? And there's the ground as well, I guess. Not really, okay. And okay, so let's come to Bandarawala here, and this is the best institute. Right? Let's say you are coming to the class. Guys coming to the class from your home to Bandarawala. I mean, just for the class, right? Without staying, you just come to the class in the morning. So it's going to be a very lengthy route, like from that Kandapola and the Kapetipola and from Valley Mada, and thereafter the Bandarvela comes to here. How long it gonna? I mean, what's the distance from your house to here? Yeah, okay. So it takes 3 hours around. So I think the distance is going to be from here to Nuwara. That's around 28 or 30 kilometers. Plus that for the Shantapura, 4 kilometers from that the junction, right? I guess. No, there's a board, right, being printed. Once you go to the right, anyhow, let's take it to be maybe 40-ish kilometers, right? Some value like that, right? So let's say, okay, somebody asks, what's the distance from this your institute that you are right now in to your home? You can say, okay, 40 kilometers, which you are indirectly saying that's the path that you need to follow, right? Are we saying direction there? No, right? We just say 40 kilometers. You don't need to say like, okay, you should come 10 kilometers and turn south and you just go another 2 kilometers due west and like that. You don't need to say that, right? You just say 40 kilometers, which is the length of this path. And that is to be a scalar here. What comes with the vector? Yeah, okay. So let's say she's very rich, so she has her own helicopter, like here. So which is being usually parked in the ground there, right? Let's say in case you need to come to the class, grab the helicopter and fly directly to here. Do you need to fly along this path where the bus comes? No, right? You can just fly directly, maybe from here all the way to the Bandarwala town. There's something called UC ground. Here now it is said to be NC ground, municipal council ground. You can lift it up from there and land it on here, and maybe you can come to her house, right? Which will take around just 5 or 10 minutes in that case. But there's a certain issue. That is, once you lift up the helicopter, there has to be a certain direction that you need to fly, right? Otherwise, you just lift it up and go straight, you might be ended up in the Colombo or maybe somewhere else, right? And that in that case, there has to be this length, which is not going to be the 40 kilometers. It will be just around 8 or 6 kilometers in that case. Maybe let's say 8 for the worst case, right? From this 8 kilometers, you should fly to a certain specific direction, targeting the MC ground in Bandara. In that case, guys, you should have the magnitude, and also you're supposed to have a direction as well. Let's take it, you have a compass, so it's the north here, and you need to take this angle that is turning. If you can remember, this is said to be the bearing, right? You should take the bearing or the bear angle always measured clockwise from the north, right? So in every helicopter there's a GPS module, and also there's a compass which directs the path, right? So Nushka here should remember, right, which side you need to turn the helicopter and fly it to land it exactly to the Bandarwell. In that case, this 8 kilometers will be having a magnitude, also a certain direction from the launch point, right? And here, in this case, this 8 kilometer also said to be the displacement, if you can remember. Later on, we're going to consider about it for the mechanics. And this, by the way, is called the distance, where the distance is just a numerical value, a measurement. We say it to be a scalar, where the displacement here has both magnitude and also a direction, which means it is to be a vector, right? That's what we are going to deal with, and more importantly, we are going to learn how we can add and subtract the vectors. We know how to add the scalars. Let's say you have 40 kilometers here. If you extend the path a little bit, you can just add that to the 40. Scalars can be added and subtracted very easily, but the vectors we need to involve with both magnitude and the direction. So we're going to learn how we can add and subtract or simply do the mathematical operations between the vectors. That's what we are going to do under this part. Okay, so since we have written the topic vectors, if not we'll write the topic vectors. It's a huge topic. I mean, to be like a main topic, and we'll write out of the measurable parameters in physics. Out of the measurable parameters in the physics, out of the measurable parameters in physics, which are fundamental or derived, which are fundamental or derived some physical parameters just have a magnitude. Some physical parameters just have a magnitude. While for some, both magnitude and direction should be considered. Should be considered. Okay, in a new line, right, or in a new point. The parameters having only a magnitude are considered as scalars. The parameters only having a magnitude are considered as scalars. We had some examples. What are the examples that you can write for the scalars? Yep. Distance. What else? Time. Good. What else? Speed and mass. We'll write them all. Okay. What else? We'll write some few. We'll write some uncommon ones. Density, pressure. Those all are scalars, right? Then we write the next point. The parameters has both magnitude and direction. The parameters has both magnitude and direction. Are considered as vectors. Are considered as vectors. Let's write some examples of that too. Very common one that you have recently heard will be the displacement. Displacement. There's another one with the displacement divided by time, if I can remember. That's velocity. Acceleration. force apart from that, some uncommon ones to be the momentum, okay, yeah, let's take those to be the examples of, and where there are dozens of examples for the vectors or for the scalars, we have written few, right? Okay, now let's try the subtopic, geometric representation of a vector. Geometric representation of a vector. Geometric representation of a vector. We are going to basically deal with, or we are going to learn how we can represent or draw a vector in your book. We need to represent the vectors. You should draw them on your book, right? So let's see how we can draw a vector. Well, it's like this. We're gonna usually use the notation to be, let's say you are drawing a vector, maybe starting here and ending up at here. We are going to show the direction by this arrow, like this, which means it is acting from this point right here to the other point. You can name it to be the 2 points A and B, and you can represent the vector AB. Usually we take the length AB to be just AB. When it is a vector, we are just drawing an arrow on the top, right? And let's say it is having a certain magnitude to be the A. For an example, it has a magnitude of 10 meters. This is a length measurement, or basically let's say it's a displacement, like the flying from a helicopter from one point to another. So you just need to fly 10 meters, right? And it is to a certain direction, so it has both magnitude and a direction where it is lining from the A to B. Then the magnitude here I could write A, and to show that it is a vector I can just underline it too. So I could write the vector AB or having the magnitude of A. Let's say it is having 10 meters, so I just need to underline the 10, not over, right? Just underline the 10, the value, to show that it is a vector. Or else you can represent it the vector AB. Got it? And guys, when you are drawing this arrow here, it has to be proportional to the magnitude, which means, let's say one vector is acting to this side with having 5, and if you represent another vector with the 10 to the same direction, it kind of has to be double the size, right? Which means you are drawing this arrow proportional to the magnitude of the vector. Higher the magnitude, lengthier the line that you are supposed to draw. Okay, and you should mark the direction to where it is been acting. Great. So we write a little note. The direction of a vector can be represented. The direction of the vector can be represented by an, can write here, head. That is an arrowhead, right? This symbol and head, or in brackets you can write arrowhead. Okay. The magnitude is represented. The magnitude is represented by a straight line. By a straight line where the length of the line corresponds to the magnitude. corresponds to the magnitude. Okay, then we write the next point. A vector starting from a vector starting from capital A pointed to the B, pointed towards the B, and with a magnitude simple A, and with a magnitude simple A is represented as, then you can write this, you can just draw this one and do this. Have you done this part for the maths? Have you done this part for the maths? I think for the applied, the very first lesson is going to be the same thing. Maths guys are kind of lucky in that case, right? So this is also the very first lesson for the applied vectors, but they are going to deal with some huge things, not just these kinds of further physics. Okay. So underneath, we'll just draw these two, showing that the length is corresponding to the magnitude. Make sure you just draw kind of like the double the size when you're drawing a 10 vector. Okay, great. Now let's write another subtopic, equal vectors. Equal vectors. Equal vectors. Well, for a scalar, we can say if two things are equal, or two length measurement, or two any measurements are equal, we can say them to be equal. For an example, let's say the length of this card here, right, and length of this card also here, let's say. So once we measure the length here and the length of this card, they will be getting the same because these are the two identical cards, right? So we can say, okay, length of this card and length of this card is equal, where you just measure the magnitude in that case, which is the length, and we can say for sure, all right, those two are equal. But when it comes to vectors, we just need to deal with, or not only the magnitude, we need to deal with the direction as well, right? And let's say if two vectors are equal, there will be few conditions it should satisfy. Right? Let's say we're going to have a vector like this AB and another vector like this CD, starting from the C and ending at the D. To make sure that this vector AB to be equal to the vector CD. Here, not that you are like kind of writing the two letters here. This is the starting letter and this is the ending letter, and showing the arrow the direction where it points. If I just write it like this way, AB to here, it is the vector aligning with the from B to A, or you can simply write it to be again like this, BA to this side. If the vector is from B to A, right? You can flip the letters, so it flips the direction of the vector. Okay, let's say here you can have like this. Okay? And how we can say, guys, the vector AB equals vector CD. The first thing it should satisfy will be the magnitude. Let's say this is having a length of, for an example, length, right? Length of 5 meters. For the scalars also, if these two equal, this is also supposed to be 5 meters, right? Which means in that case, the magnitude here is written as A, and here the magnitude is written as B. So this A has to be equal to the B. But here again, drawing an underline or underlining the value will be represent the vectors. In order to show just the magnitude, we are drawing two lines besides the value, right? This represents only the magnitude. And this thing right here is said to be the modulus, which means there's a vector, okay, 5 meters to this direction, right? But if you need to only consider the 5 meter, which is the length, not the direction, we just write like this 5, and this is a vector, guys. So 5 and the modulus. Or else simply we can write the vector AB. It's a vector. If you are interested with only the size of the vector, you are just drawing two lines, and that is to be 5. The length of the line, just like that, right? This gives only the magnitude of the vector without the direction. If you need to extract only the magnitude part, now let's say again there's a line like this, aligning from A to B, which is kind of slanted. If you don't need to take which direction the line is, but only the magnitude of the line, we represent it like this, the vector AB, and drawing two lines beside. And the two lines said to be the modulus, and we are having only the magnitude. Got it? Great. We can write these ones, so don't worry about it. Size wise, they have to be equal. And let's say this is 5 meters, so this also has to be 5 meters. What else? So vector, so we need to think of the direction too. Both of the vectors has to be aligning to the same direction. You can see one is to be like this and the other one is going like this. That can't be. So this should be towards the same direction of the vector AB, which means to that side. If it is so, I could write the AB has to be, what are these lines, guys? Going to the same direction in the same distance? Parallel lines. So the vector AB has to be parallel to the vector CD. We can just write AB line parallel to the CD. This is the second condition satisfied. In that case also, in that case only, we could write the vector AB equals to vector CD. Got it? For two vectors to be equal, they should equal in magnitude and they should be parallel. That's all. Okay, great. So we write that for the two vectors to be equal, for the two vectors to be equal, following conditions should be satisfied. Following condition should be satisfied. First one, should be homogeneous. Should be homogeneous. What's that? Homogeneous? It should be having the same parameter. Let's say we are measuring a length measurement. In this case, it is a displacement. And we have 5 newtons with the force. Can we say these two vectors are equal? No. If it is a length measurement or displacement, this also has to be a displacement. If it is a force, this also has to be a force. If it is a velocity, this also has to be a velocity. Right? It can be two parameters here. Right? That's why it says it has to be homogeneous. Right? Second point, 2 should be homogeneous. Second one, should be equal in magnitude. Should be equal in magnitude. So you could write there in front, or maybe no, we'll write later on, right? Third point should be parallel. Should be parallel. Fourth one should be acting at same direction. Should be acting at same direction. Okay. Now, yeah, we'll just draw these two. And we'll write if. This you are going to write magnitude of AB okay. So we could write like this too. AB vector magnitude equals CD vector magnitude. This is said to be the modulus. This is, yeah, just draw it, or maybe in a side you can find that. Side or below, wherever you like. Both ways you can represent same vector. You can write it to be AB line, or maybe just the A and underline. එකම තමයි කියන්නේ. AB vector එක එහෙම ඕන විදිහට represent කරනවා. AB කියලා starting and ending point ලියන්නත් පුළුවන්, නැත්නම් magnitude එක ලියලා underline කරන්නත් පුළුවන්. The same vector AB that we represent. But drawing two lines, you'll be showing the modulus, only considering the magnitude. This is how we just mathematically show it, but you can write with words too. If you finish this one, let's move to the next topic. The opposite vectors. Opposite vectors. We write if two vectors satisfy following conditions. If two vectors satisfy following conditions. They are considered to be opposite. Well, I think you quite know how we can represent the opposite vectors now, right? They has to be equal in magnitude, but opposite in direction. That means it has to be like this. One has to be aligning to the other side. Equal in magnitude, but opposite in direction. But parallel. They has to be parallel, right? It has to be parallel. Also, the direction of their acting has to be opposite. In that case, we're gonna say the two vectors are opposite vectors. So we're not writing to be equal, but we say A and B are opposite vectors, right? Okay. So we write like this: should be first point should be equal in magnitude. Wait. Should be homogeneous, right? That's the first point. Should be homogeneous. Second one, should be equal in magnitude. Opposite in direction. The third point. And parallel. Fourth point will be parallel, right? Should be parallel. Okay. Then we'll just draw these two. What happens if you have two opposite vectors? We can't just represent it then vector AB equals vector CD, right? Instead, what we could write here, guys, is what if you just add them? What if you add two opposite vectors? Let's say here, like, okay, you know what the displacement is, right? Okay, so I'm gonna make 5-meter displacement to here. And to the opposite direction, I'm gonna make another 5. What's my total displacement? 0. I have reached back to my initial point, right? So which means if you add two opposite vectors, that should give the 0. But for the time being, we just write the 0 and underlining that 0 too. There's a special reason for that. Make sure this arrow is downwards. We're gonna like the last part of this. I mean the categorizing vectors, and thereafter we're gonna have the little break and moving into how we can add and subtract the vectors. Okay, finish with this. Let's move into the last category, and those are called null vectors. Null, N-U-L-L, null vectors. That's the next subtopic. Same as earlier. Equal vectors, opposite vectors, and the null vectors. Must be a null vector. Well, you have written one already. This is said to be a null vector. What does it mean by null? Yeah, it has a magnitude because it's a vector, but has no direction. Let's take the same example. I'm just moving 5 to this side and to the opposite side 5. So towards this direction, my displacement is 0. So I should consider a direction, but the magnitude will be 0, right? While I'm just maybe while when I'm moving to this side, I can maybe go up like this and jump back. In that case, I am displacing up as well. Well, to that side, there will be a displacement. If I just retaining on that, maybe I'll just show it like this. I'm moving to this side, and when I'm returning back, I just move here like this. So I do have the displacement to this direction to be 0, but I have displaced up as well. Into that side there will be a magnitude, but towards the horizontal direction my displacement may to be 0, right? So in that case I should consider not just 0 but the direction as well. So in that case we say it to be a null vector, a vector that has a direction but has 0 magnitude. Okay, we'll write null vector. Uh, a vector has the displacement. Oh, sorry. The vector has the magnitude 0. A vector has the magnitude 0. Is considered to be a null vector. Considered to be a null vector. Next point. A null vector is represented. A null vector is represented from magnitude like 0. Why it's a vector? So just underline it. How do you say a certain vector is null then? We should check the magnitude of the vector. How do you represent? We are checking the magnitude only. We just draw two lines, and this is the modulus, and that has to be equal to 0. Not 0 vector, but 0, because we are interested with just the magnitude. Correct? Okay. So if this, right, then AB equals 0, a null vector. Great. Now we know about different types of vectors, and we're going to learn how we can do the mathematical operations between the vectors, more specifically how we can add or subtract vectors. Okay, great. Now it's 10:35. You can have a 10-minute break. Okay. Yeah. Okay. Yeah. Okay. Yeah. Sorry, my bad. They are the opposite vectors. You're supposed to ask them. I have written like I have just flipped the arrow, but I haven't flipped the letters, right? So here the CD. Sorry, guys. Yeah, thank you for asking that. It was like this. I have just flipped the arrow down, but I should write that too, right? Here the AB vector has the yeah. So AB vector plus DC vector. We usually not flip the arrow. Instead, we just flip the letters. Flipping the arrow also would work, but kind of like the general way we flip the letters, because it's a vector lining to the C to D. No, sorry, D to C. Right? Make sure you just flip the two letters, guys. Arrow also fine. Flipping the arrow also would work. Arrow එක මාරු කරන්නත් පුළුවන්. CD ලියලා arrow එක මේ පැත්තට දාන්නත් පුළුවන්. We are representing the letters lining from D to C. Or else flip the letters and remain the arrow to be same. Okay, thanks. Okay, great. We'll learn about how we can add and subtract vectors. So for the scalars, guys, right? For the scalars, we can add the scalars, subtract, or maybe multiply. Let's say if you are finding the area of this face right here, what do you need to do? Just measure the length and the breadth, which is also kind of like length, right? And you just multiply it, get the area. In that case, for this for the scalars, we do all the mathematical operations: addition, subtraction, multiplication, division. Also, the maths guys can learn something from like integration, differentiation, everything being done for the scalars. So for the vectors, guys, we only uh, in the physics we are going to consider only the addition and subtraction. There will be the multiplication as well. Maths guys learning something called the cross product and dot product, like this: I into j, that cross product is there, and I into dot j, which is the dot product. So they are learning how to multiply the vectors too. But for the physics, we just need to learn about addition and subtraction of vectors. So we write the topic there: addition and subtraction of vectors. Addition and subtraction of vectors. Well, you might be thinking of, when I say like that, you might be thinking of, okay, why not the velocity finding by the division, right? Displacement, which is a scale, a vector divided by time. In that case, usually we take it, this is a vector, but this is supposed to be a scalar. We are dividing a vector by a scalar, that's totally fine. But vector by a vector, we are not considering it, right? Okay. So let's do some example questions to know how to add or subtract vectors. So let's say we have given a vector, very simple one. Let's say 5 meters Oh, let's say this is to be a displacement, so 5 meters to this side plus another 8 meters, or maybe let's say 10 meters to the same side. What is the vector that we get? It's like 5 meters to this direction, to the right side, and another 10 to the same right side. 5 and another 10. Altogether, what's the total displacement? It's going to be 15. Well, that is getting equal to 15 meters, right? So you can write this to be like this, and like this, and like this too, which representing this to be a vector, right? Okay, which is pretty simple, and you know the notation, right? So when you are marking these arrows, make sure you just no need to be exact, but at least draw it roughly corresponding to the magnitude. Higher the magnitude, higher the length. Okay. What about then? Okay, 5 meters to this side plus 10 to the other side. Yeah, it's going to be 5 to which direction? To the opposite side. It's like 5 has been moved front and 10 has been gone back, right? So in here, guys, you can see these are kind of like two vectors which are in opposite direction. If the two vectors are in opposite direction, you can just write like this. To this side it is 5. Or if you're wondering how this 5 came, it will be like this. 5 to this side plus to the same direction minus 10, right? And this will give 5 plus minus 10, which is to be minus 5 to this side. If it is minus 5 to this side, which means you can flip the direction, it is going to be 5 to the other side. Right? I can just maybe consider only the magnitude here, like this. Got it? So when you have a vector that is in opposite direction, you can flip the direction and add the plus sign and put it to be minus. Right? Most of the time what we do is, even though we say add and subtraction of vectors, we only do the addition. Always, if there's a vector that is in opposite direction, we just flip the direction, then you can substitute that to be minus value. Got it? Where this is also something you can see. I could write the AB to be the vector AB that also equals to minus BA vector, which means I can flip the direction again and mark it to be flipping the letters. Okay, great. So yeah, we'll copy this one. This is the first one. This is the second one. Again, here you don't need to measure exactly 5 centimeters and 10 centimeters, right? Roughly represent. I'm gonna write the fifth one at the top. Okay, so anyhow, this case you're gonna have it to be just the addition to this side, 3 plus 8, which is to be 11 newtons. In this case, it is to be 20 to this side. Should be shorter a little bit. 20 to this side and 10 to the other side. So very easily, it is going to be 10 to this side. What about this? Yeah, it's supposed to be a null vector. So I'm going to put it 0 and like this, meters per second. Either you can mark it to be this direction, or maybe to the other side, or you can just leave it, write it like this. Okay. So far it's very easy, right? Finished, guys? I'm erasing the down part. Don't draw this one, right? Just don't draw. Let's say I'm going to have a vector with 10 plus. Here comes the issue, right? So if the vectors are given to the same direction, I mean at least they are parallel, we could add or subtract, basically add them, right? But when the vectors are not parallel, oh, they are acting at different directions, then is the tricky part, right? So where are the places that you're gonna see the vectors are kind of acting at different directions? Let's say it's like this. I take my camera back here. Okay, so let's say I'm gonna pull this one to this side. Meanwhile, I'm just holding it by my hand like this. So how many forces that you see here? I'm just pulling to this side, so there will be one force applied on this back to the right side. Also, I'm just holding the other side by my hand, which is kind of inclined right here, and I'm applying a force upwards, trying to pull it up. Not exactly vertical, but kind of inclined. Also, we're gonna have this has a weight, so there will be a weight acting downwards as well, right? There will be several forces acting on this bag right now, and all are acting on the same bag, right? So what if I need to consider the net force or the addition of all the forces here? In that case, you can see, guys, all of these are not vertical, right? All of them are not perfectly horizontal as well. If the forces are like this, then it is totally fine. One force to this side, another force to the other side, then it is fine, but yet we have the weight downwards, right? So like scenarios, in those cases, we have several forces, or several force is a vector, we know, right? There are several vectors acting, and they are not to the same direction, or maybe at least they are not parallel. In that case, we won't be able to use the usual procedure of addition of the vectors, right? Then we are going to learn in these kinds of scenarios, there are four methods of adding different vectors when they are not parallel to each other, and that's what we are going to learn. Okay, so we write a subtopic, methods of vector addition. Methods of vector addition. Okay, so the first one will be uh, vector triangles. Second one, parallelogram law of parallelogram law of vector addition. Right. Third one, by resolving, or by resolution or resolving. Fourth method, drawing vector polygons. Right. And today we are going to consider the vector triangles, and hopefully we'll try to do the parallelogram law of vector addition too. Right. We'll see about that. And these two methods can be used only to only for two vectors, where this method can be used for multiple vectors. When you have just two vectors, we can use this method, either this. But if you have more than one, more than two, we can use the resolving method or the drawing of vector polygons. Okay, so we write them all, and in front you can write only for two vectors. All right. Then we write a little point underneath. addition of two or multiple vectors. Addition of two or multiple vectors represents the net effect. Represents the net effect of all those vectors. Yeah. Addition of two or multiple vectors represents the net effect of all those vectors by a single vector. By a single vector known as the and you can switch the colors, resultant. Resultant vector. So all we do here is, let's say we have a couple of vectors. By adding them, we just represent all the effect of those vectors by a single vector. That's what we are going to do, which is known as the resultant, right? And let's see how we can find out the resultant from each of these methods. That's what we are going to do. We basically need to add the vectors now. So by adding, we show that the effect of, let's say, a few vectors by a single vector, which is shown in the resultant, right? So here, by each of this method, we are interested in finding the resultant. Okay. So we write the first subtopic then, vector triangles. Vector triangles. And we'll write the definition for that. How we are going to define the vector triangles, right? When the two given vectors, I told you this is being used for two vectors, right? When the two given vectors are represented as two adjacent sides of a triangle. Two adjacent sides of a triangle the third side joining the starting and the ending points. The third side joining the starting and the ending points completing the vector triangle. Completing the vector triangle. Gives the resultant of the first two vectors. Gives the resultant of the first two vectors. Great. So it is like this. Let's say now we have one vector which is named as the A, plus there's another vector that is represented as the B, and with a certain inclination, maybe theta. Do you know this symbol? It's again a Greek letter. We say theta. Theta, right? Sorry, ta. Double E has to be, right? I'm not sure. Theta or T-E-A, ta, whatever, right? It's a Greek letter again. You know, guys, during the physics, we need to learn different Greek letters as well. Kind of like not all the Greek letters. There are around 28 Greek letters, and out of that, we're gonna learn few things, few letters, because most of the physicians they lived in the Greece during the Newton's era and all, right? So that's why they have used their alphabet, the symbols of their alphabet. Maybe let's say a Sri Lankan found this one. Maybe you can write R or maybe U, whatever, right? But yeah, it's some Greek symbols. This is called the theta, usually putting for the angles, right? Let's say it is inclined with the angle theta to the horizontal. So we basically need to add these two vectors. So by this vector triangle thing, what we are doing here is representing the two given vectors as two adjacent sides of a triangle, which means I can construct a triangle like this. I'm going to start it from here. Then I'm going to draw the the vector A, all the way from here to here. And we know all these vectors are representing here the magnitude, and also we are drawing this line proportional to the magnitude as well, and also towards the direction of the application. So here, starting from this point and ending at here, I have drawn the vector A. Thereafter, I should draw the vector B. Right? I have stopped from here. Then from there onwards, I should draw the next vector. Should be have the same inclination. Vector B. And it stops from here. For an example, guys, let's say this is to be 20 meters. So we are drawing a line that is corresponding to 20 meters and stops from here. Right? Let's say this angle is 30 degrees. So you're gonna have a protector here, place it there, mark that 30, and let's say this length is just 5 meters or maybe let's say 10 meters. It's a displacement to this side, let's say. So if you have used 20 centimeters to draw this line, or maybe let's say 80 newtons, then it is working well, right? If you have here 20 newtons now, let's say you are using 20 centimeters to represent this 20 newtons, and this is 10 newtons. So let's say you are using 10 centimeters to represent that 10 newtons. We know the line has to be proportional to the magnitude. If you use 1 centimeter for 1 newton, this will be 20 centimeters, this will be 10 centimeters representing that 10 newton, right? Okay, fine. So here, to generalize the scenario, I'll put here the theta. And we don't have yet the triangle. How to construct a triangle? Yeah. Now we have represent the given two vectors as the two adjacent sides of a triangle. To complete up the triangle, we need to have the third side. From where to where? From the starting point and the ending point. So I can draw the line to be like this. And since it gives the resultant or the addition of these two vectors, I can represent it with double arrows. Right? So by the vector triangle, it says if you just represent the two given vectors as the two adjacent sides of this triangle, the third side, which is complete in the triangle, should give the resultant in both magnitude and direction. Right? Didn't we write that resultant of the two forces vectors in magnitude and direction? We'll complete that too. In magnitude and direction, right? Which means, guys, again, if you have drawn this to be representing the 20 newtons, which is let's say 20 centimeters, this is represented with the exact inclination measured by a protractor too. Let's say you have drawn 10 centimeters. After that one, you can complete the third side, right? And the magnitude of that, which means you can measure this to be the meter ruler, so you can measure it from here to here, which gives the magnitude. Also the direction, you can keep the protector here and measure up this angle, and it gives the direction, the inclination to the horizontal. Right? So basically it's a representation. අපි triangle එකක් හදිනවා මේ sides වලට proportional වෙන්න. So finally the resultant should be given by the length of this side, which is given the magnitude. Also the inclination gives the direction. Got it? Okay. So let's kind of generalize the scenario, and we'll do it with the example too, right? Some numerical values. For the time being, I'll just put here the vector to be the c. So all I could write here is the vector a plus the vector b has to be equal to the vector c. Right? If I put some letters here, let's say this is a, b and c here. So I'm going from a to b, that is the vector ab plus vector bc, supposed to be equal to what? The vector ac. It's kind of easier to get, right? You have the b here and b here, kind of merging it with the first letter and the last letter, ac, without the b. Right? You just go from a to b, b to c, then the resultant will be a to c. Pretty simple, right? Let's say a person is walking like this. He just walk from here to here, then here to there. So the total displacement will be from here to here. Okay, pretty simple. Okay, let's copy it down. Guys, there is this one. And let's do one example question. We're gonna have here, so could be newtons or could be displacement, whatever, right? Plus, uh, let's say we're gonna have to this side, maybe 5. With the inclination of, let's say, 30 degrees. Then what we supposed to do? We should do it like this, right? We should construct a triangle. Well, we're gonna have all the way 12 to here, 12. And thereafter, this is the ending point. You are going to draw that 5 to this side with that inclination of 30 degrees, like that. So what should be the resultant or the addition of these two vectors? It has to be from here, join the ending point. So since it is the resultant, you can put there capital R, right? And maybe underline, right? Okay guys, so how do we find it? Well, there are two methods that you can do this. One is, as I told you earlier, you can represent this 12 in exactly maybe 12 centimeters. And afterward you need to have a protractor, measure a 30-degree angle and mark it. And if it is 5, you can mark maybe 5 centimeters here. And construct the triangle and measure up this length. And that gives the resultant. Let's say we got here, for an example, right? Let's say we got here to be 18 centimeters, which means 1 centimeter represent 1 unit here. Because 12, we have used 12 centimeters. 5, we have used 5 centimeters. If it is proportional, if this is 18, the resultant of this has to be, the magnitude has to be 18. Correct? And what's the direction? You can keep the protractor here and we can measure this angle. That's one way of doing it, which is kind of like a constructive method, right? Like a construction that you do. But in the exams, we are kind of dealing in the time. Also, let's say, we know that every measurement has a error, right? Every measurement has an error. So, let's say you are measuring this 12 centimeters and again 5 centimeters. There could be a slight fluctuation with the marks. In that case, this reading also going to be a little bit varying. And also, it's kind of time consuming to measure up these distances and all, right? Also, you need to play with some sort of scenario, like say you need to mark this 30 degrees and sometimes you need to mark the angle bisectors also. So you need to deal with the O-level chemistry too, with the constructions. And apart from like drawing it in a specific scale, we could use the knowledge of the trigonometry. Instead of drawing and measuring the values, we can just sketch it and calculate the values using the trigonometry, right? So if you can remember, there are few trigonometric ratios that we have learned already. Can you remember what are them? If you have a right angle triangle here and a theta, and let's say this is A, B and C, or maybe X, Y and Z. What are the main trigonometric ratios we have then? Sine theta, cos theta and tan theta. How do you write the sine theta? Opposite? Yes, opposite over hypotenuse. Which in this scenario, the opposite side is going to be the side opposite to the angle seen from the theta, which is the x. Hypotenuse is the top side, which is the z. And cos theta is what? Adjacent side, adjacent over hypotenuse, which is the adjacent side here, the side that is just touching the angle. Yes, the y. y over z, right? What's tan theta? Opposite over, yeah, good, adjacent, which is the opposite side x, the adjacent side will be the y, right? You can use these trigonometric ratios to find out this r right here. For that one, guys, we supposed to have a right angle triangle, otherwise we can't define a hypotenuse, right? So in this diagram we don't see a right angle triangle, but you can construct one. I can just extend this line and this line too, and kind of makes a 90 degree, right? Okay, so the triangle that I have constructed, this r is going to be what? Is going to be the hypotenuse, right? Same as this, right? The longest side of the right angle triangle is going to be the hypotenuse. Here the longest side is this one. So you could find out this hypotenuse whenever you see a right angle triangle. The Pythagoras is there, right? So we could be able to apply Pythagoras if you know the entire this side, also this side, right? Then I could put here to be the x and here to be the y, right? If you see the smaller triangle here, the little triangle, maybe I'll name this one like A, B, C, and this is the D. If I consider the B, D, C triangle, if I write the sine theta, sine here theta is what? Sine 30, right? Sine 30. That will be what? X over 5. So I could write here, this is to be the CD over the BC. So sine 30 equals to x over 5. So I could find the x by cross multiplying this part to the other side, which is going to be 5 sine 30. Correct? So x right here is then going to be 5 times sine 30. And I could write instead with this y, guys, how I could write it? Y එක ලියන්නේ කොහොමද? We know this side, which is the hypotenuse. This y is going to be the adjacent side to the 30. So adjacent and hypotenuse gives the cos, right? So in the same triangle, I could write cos 30, which is going to be equal to BD over BC. So cos 30 equals to BD, which is y over 5, right? Okay. So usually we take this side to be the x-axis. So let me just flip the letters. This is x and y. Then it will be good, I guess. Here also like that, right? Y, x, and sign will be y over z. I mean for the convention, right? So this is x over z. Then this is y over x. Usually we take this is to be the x-axis of a angle, right? And yeah, then this is going to be y. So y equals 5 sine 30. Here I could write x. Then x here is, guys, 5 cos 30. Here in this case it is going to be 5 cos 30. What's sine 30 and what's cos 30, guys? Yes, so in that case we should have the same tables, right? The trigonometric tables, and you can refer the sine 30 and the cos 30 also. Right? Wait. Okay. You can get the value, right? Sine 30 means you should go to the natural signs and see 30 0. 0.5, right? It has to be 0.5. Okay, so I just said this one like I am having a certain memory, right? It is to be 0.5. Yes, guys, so it has to be. You should remember, now always we can't refer the sine tables or the cos tables, right? The opposite of the sine table is going to be the cos table. So instead, throughout this physics course, throughout the entire physics thing, right? Entire physics syllabus, we need to deal with some special angles. So you're supposed to know the values of those angles. Okay. So before all these stuffs, these are the angles that we need to remember. The 0 degrees, then 30 degrees, then 45, and 60 degrees. Also, we need to remember the value of the 90 degree. What are the main trigonometric ratios we know? Sine, cos, and tan, right? So we should know sine value, the cos values, and the tan values. Right? So this is the angle and this is the trigonometric ratio. So how to read this table? Sine 0, sine 30, sine 45, sine 60, sine 90 will be filled with this row. Cos 0, cos 30, cos 45, cos 60. Likewise, the cos values will be filled with this same row, right? And so as the tan values. Alright, so sine 0, if you just refer that table, 0 degree will be just 0. Sine 30, you can see to be 0.5. So it's kind of inconvenient to deal with the decimals. Instead, if it is good to be, it's good to be kept in the fractional form. So I can write the 0.5 to be half. So as sine 45, that will be coming by 1 over root 2. Right? There will be a value for the sine 45 and that will be given if you take the division 1 divided by the root 2. Also, sine 60 is going to be something root 3 over 2 and sine 90 is going to be 1. And cos 0 is, guys, that is really easy. Once you fill up this, guys, once you fill up these sine values, all you need to do is flip this one to write for the cos. Which means cos 0 is what? 1. Cos 30 is root 3 over 2. Then if you flip it, the same value comes to here, right? So that is going to be 1 over root 2. This is going to be half. Then cos 90 is 0. Got it? Once you fill up the sign values, it's kind of like flipping it and guess this. Then the tan. Tan 0 is 0. Tan 30 is 1 over root 3. And tan 45 is 1. Tan 60 is root 3. And tan 90 is said to be not defined for the maths. But for the physics, we're gonna say it to be this. What's that? It has been turned. No, it is said to be infinity. Right? Okay. So, are we supposed to remember this value? Yes, guys, definitely. Right? Because for the entire physics series, right, entire physics lessons, we need to deal with these special angles, with these ratios. You need to make sure to remember each and every value. Also, when finding the angles, we have this root 2 and we have this root 3 as well. And sometimes there are scenarios we need to deal with the root 5. Also, sometimes the root 10. You're supposed to know these values as well. Do you know what's root 2? It is 1.414. It's better you could just remember at least up to 2 decimal places. Root 3 is 1.732 because we need to have this root 3 substituted here, right? That's why you need to remember those values. Root 5 is 2.24, right? Root 10 is 3.14, which is kind of roughly equal to the value of the pi, 2207. Not exactly equal, but at least for few decimal places. So you're supposed to remember all these values too. So it's time for us to copy this table. Also, I'm just recommending you to prepare a little piece of sheet again and paste it on the wall. Display it for just 1 week. Not more than one, right? Otherwise, always you just sin 30 and do it. Right? You get the practice to refer the table. No, this is just to display, right? සතියක් ප්‍රදර්ශනය කරන්න wall එකේ. That's all. Afterward, you need to remove it and you need to keep it by mind. Okay, guys, these values too. It's better you could just remember up to 2 decimal places. That's totally fine. Well, once the other copy it down, you can see that there's a certain order, right? We have 2, then root 2, then root 3 over 2. Here the opposite. And here 1 over root 3, then root 3 is not there, then root 3 comes, like that. Right? Great. Okay. So, I should keep these also, right? Maybe I'll just erase this part. Now let's see how we can do this one. So I think you didn't copy this one down, right? No, right? Great. So we'll copy it. We'll just make it to be 6 here, and it is going to be easier for us. And we'll make it to be 60, since it is the first example. Okay. Now we'll draw. here 60, and here 6. Only this, right? And in a side you can write this. මේක අඳින්න මෙහෙම, right? මේ ටික ලියන්න එපා. This is a side note in case if you need. Now guys, let's put here X and Y using another color, right? And thereafter you can write considering the BDE triangle. Considering the BDC triangle. Use the same color here, the X and Y, the same color you can write here, which is kind of clear for you to understand, right? In here, I can take sine 60 equals what? Opposite DC or CD over hypotenuse BC. So sine 60 equals DC, which is Y over hypotenuse BC 6. So Y equals 6 times sine 60. What is sine 60, guys? We know now. It is sine 60. That's root 3 over 2. So it is 6 into root 3 over 2. Then 2 and this 6 cancels off. It's 3. So it is going to be 3 root 3. Got it? Can you see the board? Okay. So this is going to be, so in same the color, you can write 3 root 3. Then similarly you can consider the cos 60. Write it. That's BD over BC. So cos 60 equals BD, that is x over BC, that is 6. So x equals to 6 times cos 60. So 6 times cos 60 is what, guys? Cos 60 is half. That is just 3 then. So this is going to be 3. Okay. Now our hunt is to find the R, right? The resultant. But we have to do all the way up to here to get it there. So how do we find the R then? Which triangle I should consider? The large triangle, right? Then considering A, D, C triangle. A, D, C triangle, the large triangle, because there's the place that we have that right angle, right? Okay. So what I could write? AC squared is equals to, yeah, AD squared plus DC squared or CD squared by the Pythagoras theorem. Then AC squared is the R squared, guys. How do we write the AD squared? AD, the entire length, to be 12 plus this 3 we have found out, right? So it's going to be 12 plus 3 and the entire thing squared plus DC squared, and that is 3 root 3 squared. Okay, now let's simplify. Three squared is going to be 9. Root 3 squared, here 3 root 3 is like this. 3 root 3 squared means 3 squared into root 3 squared. So this is 9, this is into 3, which is 27. Okay. Square of 15 is 225, right? Yes. So it is going to be 9 into 3, which is 27. Can you guys see here if I write? 225 plus 27. Add it. Then R squared is going to be equal to 230 No, sorry. 259. No, wait. 252. Okay, great. So what's the R then? That is root 252. Okay. If it is the exam, guys, you will be given the square root of not this. Instead, they will give something like this. Take square root of 63 is to be, let me find that one out. Something with 8, right? No, 7. You will be given this one to be 7.9. But not this. Then how we can find out the answer? Well, I told you, if it is the exam, they will give a simplified square root, not the square root value that you're going to get after this. So which means there has to be a way to make this 63 out of this one. Yes. So always, how we can escape out from a square root? Make a perfect square inside. What are the perfect squares you know? We can write 1 squared, which is just 1. Then we have 2 squared, which is 4. And 3 squared, which is 9. And so on, right? So think whether you could just divide this one by 1. By dividing 1 doesn't make any sense, right? Yes. So try then whether you can divide this one by 4. That's the first thing you can try. Is it divisible by 4? Yes, it is. So then R you can write R equals this to be 4 into 63 and root. So what is 4 root? Yeah, that's 4. I could write 2 squared. 2 squared taking the root, it is going to be 2 root 63. And as for the exams, this will be kind of given. Now here I have given it. So it is 2 into 7.393. Okay. 86. This is the value of the resultant, or simply the magnitude of the resultant. Okay. Are we satisfied yet? No. Why? These are vectors, guys. So saying only the resultant, the magnitude of the resultant will not work. We have found that, okay, this is 15.86. But we should give a direction as well. So let me mark a direction here, and I can put a certain angle. Let's say it is alpha. Right? This is the alpha mark, right? It's the first letter of the Greek alphabet, the alpha. Okay. So if I just write the alpha, what trigonometric ratio I could write there easily? From the same ADC triangle, I could write any of the trigonometric ratios, right? I could write the cos, I could write the sine. Why? Sine is going to be for this alpha, which is the opposite side. This one, the CD, the opposite side. What is the adjacent side? The side that is just touching the alpha, which is to be the AD. Do we know the hypotenuse also? Yes, which we have recently found out to be this. So you could write whatever the trigonometric ratio, sine, cos or tan. But this resultant came by all the way from here. There might be a chance that this could be calculated wrong during each of the processes, right? So if you use this value to find out the angle here, which you could write simply the sine, which is this over this, sine alpha, but you are like writing a wrong value in that case, so you will lose the mark for both answers. So it's better you could just have it without the resultant. So the best thing you could write here will be the tan. So I could write the tan alpha again by considering the ADC triangle. Tan alpha will be what? Simply CD over AD, which is 3 root 3 over 15, right? Now we can simplify this one a little bit further. This is to be 5, and tan alpha then going to be equal to root 3 over 5. So it's only sufficient to write until this one, or else you can write then the alpha equals tan inverse root 3 over 5. Right. Okay, now we have done the fair because we have been calculated the magnitude. Also, we have calculated the direction to the horizontal. How much it is being inclined, the resultant to the horizontal, and that's how we represent a vector in magnitude and the direction. Okay, let's copy them down eventually. Also, at home you can find out the exact alpha value, this one, right? How? Because you know the root 3 I have given you. Divide it by 5 and find the tan inverse from the trigonometric tables that I have given you. And make sure guys you are taking you are always bringing the book, the trigonometric table book that I have given you today until we finish up this part, the vectors, in case, right? While you're writing, just listen. I told you, display this one for a week, which means we're gonna see you by the next week. Then you should be able to memorize these values. I'm just asking some random people to fill up the table, right? So that you should remember those values as well. Also the root 3, root 2, root 5 and root 10. Okay, so I'm gonna give you some homeworks and we're gonna wind up for today, right? It's almost about 12:30. We have just around 14 minutes left, and for that time we can use it to mark down the homeworks. Also, there will be some homeworks I will be giving. Shall I erase this one? Right. All good. බලන්න ඔක්කොම ලියලාද කියලා මොකක්වත් මිස් වෙලා නැද්ද කියලා. Yep. හරි නේද? ඔක්කොම ලියලා තියෙන්නේ? මොකද මිස් වෙලා නැහැ? Okay, great. So we'll quickly have a recap, guys. What we supposed to do first? Very first thing is we should represent the two given vectors as two adjacent sides of a triangle and complete the third side. And if there's no any right angle triangle there, complete one or construct one right angle triangle and find the missing sides from the trigonometric ratios, the sine, cos and tan. And always, if there's a right angle triangle, use the Pythagoras theorem to find out the hypotenuse. And most of the time, guys, the resultant will be given by the hypotenuse. And most of the time, there are some scenarios it is not been happening, but most of the time it will be. Okay. We write these are the homeworks. We have done the first one, so this is the second question maybe. It's 12 to this side plus 5 to vertically up. You can just represent it like a right angle here or without that, just vertically up. Shall we quickly construct the triangle and draw its sides? කොහොමද මේකේ triangle එක කියන එක ටක් ගාලා අඳින්න පුළුවන්ද? Just the triangle? 12, then fine. Easy peasy, right? Luckily in here, you will see a right angle already. So what's the resultant? This one. What's the value? If I say 13, do you believe me? Yes. How do you say so? Yeah, we can, it's better you could remember that Pythagoras triple as well, right? Which is 3, 4, 5, like 5, 12, 13, 6, 8, 10. These are called Pythagoras triple, right? So we are not doing a pair. If you just say only the magnitude, find the direction as well, tan alpha, right? Actually, we have already done that question, but just write it, right? A, B, C, and some things. Next one, third one. It's the same 12 and 5 plus. Now the 5 is been to this side. To kind of like, this is 120 degrees. Okay, these are just the two homeworks that I am giving you, and there are a couple of questions in the tute. We'll come to the first page. Very first page. And you can do the very first question. What are scalars? Give 5 examples, right? What are vectors? And you can do that. And third one and the fourth one. Fourth one, it is asking construct the equation used to find out the magnitude of the sum of two vectors. Right. Third, fourth part. First question, fourth part එකේ තියෙනවා construct an equation. Okay. First question, fourth part එකේ තියෙනවා, right? Construct the equation used to find the magnitude of sum of two vectors. Right? So which means the same procedure here, guys. You can mark any vector to be like that, or maybe A, B, C, D, right? And the sine, cos, theta, and so on. Try to build up the equation. If not, totally fine. Right? Just try it. Worth a trying. If you can't do it, don't like spend the entire day of thinking about it. Okay, I can't do physics like that. Right? If not, just leave it. We'll discuss. Right? Try to get it within, okay, maybe 10 to 15 minutes. If you can't, just leave it, right? Make a circle there. And you can do the second one Third one, you can see in this second one and third one, guys, it is not mentioning about this 12 and 5 like with this. Instead, they say with the words, right? So, especially there will be saying about the directions. So, I guess you are okay with the directions, right? That උපුල් ඊළඟ නැවෙන් යන scene එක පුළුවන් නේද? North, this is east, south, this is west, right? You should know the major directions and yeah, that's all we need. Okay, fine. So you can do the third, fourth, fifth. Sorry, fourth one. Until the fourth one, you can't do the fifth one yet. And the sixth one, seventh one, eighth one, 8, and 9, and also 10. Right? Then afterward, you can do the MCQs starting on the page 7. Page 7 එකට එන්න. You can try from the first question to the 8th question. There are 8 MCQs. Yeah, I guess that's all you can try for now. Another lucky week, I guess, right? Having less homework. Make sure you just finish up every question in this tube, the previous tube that I have given you the measurements, right? And feel free to ask any question that you have. Just finish the tubes once you leave it, right? Tube එක අයින් කරනකොට ඒකේ වැඩ සම්පූර්ණ ඉවර කරලා අයින් කරන්න. Otherwise, things are going to be stacking up, right? Don't leave any question behind without being tried. Always feel free to ask any doubt that you have. Just send me via WhatsApp, just the question number or maybe the entire question taking a photo. And I'll put that links to the group. And when it is convenient for you, just buy those books as well. It will be really important. Especially buy a past paper book for the physics and also for the other 2 subjects. How about the homework? 8:30. Okay. What else? What other doubts that you have? What is it? Okay. Okay. How about it? Which means which question? Last 3 means 9, 10, and 11. Okay. So they basically mention, okay, let's say 2 vectors of magnitude 12 and 6 are inclined to each other. That means you can consider it's since it is not mentioning anything about the direction, you can consider this to be the 12 and the other to be the 6, right? And this is the direction of the 12, the other one is kind of 6 like this, right? Incline 30 degrees to the 12. So you can take 12 and thereafter the 6 like this. This is the resultant. Here it's going to be the 30. So you can see here this 6 is kind of inclined 30 degrees to the with the 20, right? So today we're going to be deriving another equation, and from that you can do this one very easily rather than rather than just drawing a triangle. But I just mentioned in case I mean you are kind of getting confidence with this one once you tried many questions, right? There are other methods that we can do. If you can remember, we have considered about 4 things, right? 4 methods of vector addition. Out of that 4, we have just considered the first one, right? Uh, let's see some simple questions. Have you tried the MCQs on page 7? I have given little MCQs to try. Have you? Okay, good, good. So you couldn't? Oh, next time just fold the page or maybe like put a mark, right? Otherwise, always there will be MCQs and essay questions. Right? Okay, so how about the 6th one, guys? Did you try it? I think. Okay. How only? 5th one. Hmm. Okay, we'll try. We'll try. We'll see the 6th one first. It are only scalars it is asking. So if you just see the first combination, the first choice, it is saying that velocity, momentum. So this should ring a bell from your O levels as well, right? We're gonna be learning about the momentum. We're gonna be learning the velocity as well, right? In a future lesson. But currently, I guess you know, right, about the vectors. The first choice is velocity is a vector, momentum is a vector, pressure seems to be a vector. Okay, so do you know how we get the pressure? I mean, usually, how we calculate the pressure? Pressure equals force divided by area, right? So out of these two guys, what about the force? Is it a vector or a scalar? It's a vector. What about the area? Area of this table? Are you not sure? It's supposed to be a scalar, right? So usually we are going to learn, like, let's say ask the area of this table, we just measure the length and the breadth and we just multiply it and say in the area, right? So yeah, guys, it's totally okay. For the A levels also, we're gonna be learning this area is also as a scalar, right? This is a vector. So vector divided by a scalar gives a supposed to be a. If you divide a vector by a scalar, what you're gonna have? Let's say we are finding the velocity, if you can remember. Velocity equals to displacement divided by time, right? So here the displacement was a vector and the time is a scalar. So the velocity has to be a vector. So if you just divide a vector by a scalar, which is just a numerical value, then that's supposed to give a vector, right? So with that perspective, we can think of, okay, the pressure is also a vector because this is a vector, this is a scalar, and this will be a vector, right? But yeah, that's the thing we are going to learn. So even though we learn the area to be a scalar, even for the A levels. But once you go for higher studies, maybe from the math stream, the very first lesson they're gonna have, I mean, in the first, let's say they go for engineering. I think all of you are doing bio, right? Okay. So once the math student go to their universities and maybe go into the engineering field, and in the very first year there will be a lesson called vectors, right? In the first semester, and for that one they're going to be learning the area to be a vector, because we should consider the area in a 3D space, which means if you say the area of this table right here, not just the magnitude, we should say a specific direction. Okay, we need to, like, with the axis, or maybe let's say this tape, this wall here as the reference, I should consider from this wall this much to this area, and from this wall a certain value for this area, right? I should say the position as well if you just consider something in the 3D space, right? You guys also have a certain position right now, right, with respect to these walls. Likewise, there we're going to consider this area to be a vector. So there's a vector divided by a vector. So this comes with a scalar. Again, we're going to learn it in a later part called hydrostatics and fluid dynamics, in the last part of the mechanics, right? There you're going to be learning this is to be a scalar. But if somebody asks, what about the area? Area is definitely a scalar, right? You say like that because that's what we need to learn for the A levels. Right? This is to be a scalar. The area is a scalar, right? Okay, so regarding the first choice, pressure is a scalar, other all are vectors, so that won't come. Acceleration, relative velocity, momentum, energy, electric field intensity. I guess you don't know about the electric field intensity. For the time being, we'll just write them, right? Acceleration is a vector. You can put there v if you need, right? So it kind of gives the idea. Acceleration is a v, that means a vector. Velocity, relative velocity, it's again a velocity, so it's a vector. Momentum is a vector. Electric field intensity is also a vector, but the energy is a scalar. Third choice, relative velocity, displacement, acceleration, momentum, and force. Yes, that's supposed to be the answer. All those are vectors. Fourth one, the acceleration is a vector, velocity is a vector, momentum is a vector, heat. Heat is an energy, so it is a scalar. Electric charge is also a scalar. The last one, energy, electric charge, pressure, velocity, force, all those, the last three are vectors, the first two are scalars. Okay. So yeah, it's the third choice. Let's see the fifth one then, as you have requested. Fifth question. Consider the following statement about vectors and scalar quantities. A scalar has only a magnitude. That's correct, no? So the A is true. It's asking which E's are true, so A is true. A comes. So you can just neglect the second choice, the third choice. All we are left with the first, fourth, and fifth. That's how we do the MCQs, right? It's better you could just use the elimination method, where you can remove out the unnecessary answers. Then it's gonna narrow the search, right? So the B will be the vector's quantity has both magnitude and direction. It's also true, right? What about the last one? So it's just 4, or maybe the fifth choice, right? Then if the C is true, the fifth choice comes. If not, the 4. When a set of vectors is multiplied by a scalar quantity, the set of vectors is obtained. Yes, that's supposed to be, guys. When you divide a vector by a scalar, or when you multiply a vector by a scalar, it's just multiplying the value with a certain number. That's all, right? So the result will be again a vector, which means the C is true. So all the 5 choices should come. Then the answer is the fifth one. Except there's one scenario you're gonna have. Yeah. Okay, that's totally fine. Uh, we're gonna learn something with something called work later on, and that is with the force into displacement. And if you can remember, guys, all those equations were there in the very first unit to prove them to be dimensionally correct. I think Rashmi knows about it, right? And you guys also received the very first unit. There was questions about that. So kind of like almost all the equations that we're gonna encounter within the syllabus are given there. So here we're gonna see it is a vector, and here it is to be again a vector, and this is to be a scalar. Work is a scalar, right? So it's a multiplication between vector and a vector, and bio student doesn't suppose like don't supposed to know this one, but there could be two multiplication. One is like cross product, and the other one is the dot product. Right? Don't be messed up, right? Too much. When you're gonna have like dot product between the vector two vectors, it is going to give a scalar, and when you're gonna have a cross product, it is going to be a vector, right? So even though we just write it like this, it has to be the dot product, but we are not interested with that. Just put in the multiplication, right? They know about it, but not supposed to discuss in the physics syllabus. Okay, great. So yeah, we'll. Any other doubts that you have? Yes. Yes. Uh, there are also the velocity we're gonna have as the dot product. So it's a velocity into velocity. So kind of gives the scalar quantity. Right? That's how it came. Good question. Okay. So I guess that's pretty much it we need to learn, right? I mean, to discuss as the questions, we can move to the previous theory. Okay, the first one, fourth part. Okay. Yeah. Construct the equation to use to find the magnitude of the sum of two vectors, right? Uh, okay, so we can do this one from the triangle law. Yeah, we'll do it in the triangle law. And we also can get the same equation from the next thing, which if you can remember, that's called the parallelogram law of vector addition, right? They also we're gonna derive an equation which comes with the same as the triangle law. What do you prefer, to discuss it with the triangle law or go with the parallelogram law? Okay, great. I'll just teach you the triangle law, and I think it will be helpful. It will be really easy for us to derive the equation for the parallelogram law, which is the second one we need to learn, right, guys? Okay, so I'm gonna generalize the scenario here, where we have given, let's say, two vectors. We're supposed to find the magnitude of that, right? So we can consider any arbitrary vectors to be maybe, let's say, to this side p, plus to this side it is the q. We're supposed to show them to be vectors, so like this. And let's say this is inclined with an angle theta. So we're supposed to get the addition of these two vectors, and we should show how the resultant comes. What's the thing we are going to do, guys? Yeah, we're going to construct the vector triangle here. So starting point will be this, and I have drawn the P. Then after to this side, it's going to be the Q. Okay, with the inclination theta to the horizontal. What gives the resultant, guys? The line that is joining the starting point and the ending point here. So I'm gonna mark it to be the R, showing that it is the resultant. Also, these are vectors, right? This is P and this is R. So we're supposed to get the magnitude, so I'm not interested much with taking only the considering I'm just considering about the magnitude of these vectors, so I'm not marking them as vectors. Instead, I have just written as the magnitude, right? Okay, so how did we do this one? Lastly, to apply any trigonometric ratio, we supposed to have a right angle triangle. We don't see right now, so we can construct one, right? Going to be like this, like this. Okay, then I have put here y and I have put here to be the x, and we got to know how we can write down the x and y. Earlier case we have done this with the values, but right now we just gonna put some symbols here and kind of like derive a generalized equation, so you can just put the values there and get the answer. That's what we are trying to do. Okay, so how do we write the x then? X and q are coming with the cos theta, because x is the adjacent side, the q is the hypotenuse, right? So it's x over q. So x is equal to then q cos theta. Similarly, I could write the y with this theta. If you just see from the theta, the y will be the opposite side and the q will be the hypotenuse. So it is sine theta equals y over q. So y is equal to q sine theta. Then this is going to be the q sine theta, and this is going to be the q cos theta. Right? Then what? If you need to write the r, we should write the addition of this side squared plus the other side squared from the Pythagoras, right? So I'm gonna put some letters like A, B, C. This is to be, let's say, B, and this is C maybe. So I can consider the A. Oops. This has to be the D, right? ADC triangle, similar thing we have done last day, right? And applying Pythagoras. Pythagoras equation, right? How do you write? AC squared equals, come on guys, what's AD squared plus, or CD or DC or CD, okay, squared. AC squared, and that is going to be the R squared that we have written, equals AD. I could write that to be AB plus BD squared plus CD squared. Okay, I just substitute in the next page like this. Okay, CD squared. Okay, great. So it is R squared equals, that's AB is P plus BD is what? Q cos theta squared plus CD, that's Q sin theta squared, right? Okay, so we're gonna have here two terms and square. How we simplify that bracket? It's like A plus B squared. I guess you know the poem. Yeah, first term squared, that's 2 times first term into second term, yes, A into B plus B squared, the last term squared, right? Okay, let's do that. First term, which is the P, right? So P squared plus 2P Q cos theta. This is a single term, right? This is supposed to be like the B, and this is like the A. Okay? So P squared plus 2PQ cos theta plus, we're supposed to square the entire thing here. Q cos theta, the entire thing squared. Plus, we're gonna have the Q sin theta squared. Okay, so we're gonna have P squared plus 2PQ cos theta. I can square the here, it's like maybe like x into y squared. How do you write this? maybe I could write x squared into y squared, right? I can separate the square and write individually. It's like then plus q squared cos squared theta, because we should square this, also this, plus q squared sine squared theta. Okay, great. So I'm going to do it like this. I should simplify this even more, right? I'm going to take it like this, p squared plus q squared, and you're going to see here q squared is common for both. And I could write sine squared theta plus cos squared theta. I have just split the terms. It's okay, right? Just the addition. Plus 2pq cos theta. Right? And now we have ended up with sine squared theta plus cos squared theta. Well, if the Jishnakshan were here, he will tell, because that's going to be a kind of like again a first lesson for the math students. In the A levels, they're gonna learn about something, some trigonometric identities, we say. For the physics also, we're supposed to learn mainly two trigonometric identities and some equations with that, right? One will be encountering at here. The another one will be in a future lesson, something called projectiles, right? So yeah, these are the trigonometric identities you're supposed to remember. The first one is this one. When you're gonna have sine squared theta plus the cos squared theta, the same angle, that will give 1. Don't believe me, guys? Let's apply with a certain value here. Let's say I'm going to take this theta to be 45. Here comes checking your knowledge, right? Okay, what's sine 45 then? One over root 2. Okay, 1 over root 2, right? Plus cos squared 45. What's cos squared 45? I mean cos 45. Okay, same thing, right? Okay, I'm just checking here, substituting the theta to be 45, whether I'm getting the 1. Okay, so we're gonna have here 1 over root 2 squared plus cos squared 45, that is also 1 over root 2, and we're supposed to square it. What we're gonna have here? Can you guys see this? Okay, so what we're gonna have? 1 over 2 plus 1 over 2, because square root square, the square root cancels off. So half of a cake, we're gonna have the full cake, right? Which means we're gonna have 1. Right? This is not just for the for the 45, you can substitute any angle, maybe like 30 here, right? Then sine squared 30, cos squared 30. This will be valid for almost any angle. So we can say this is to be a trigonometric identity. So for any angle, this is true, right? And you don't need to remember the proof. All you need to remember is the identity here. And there are going to be another one which we gonna recently, very soon going to learn, and that is sine 2 theta, and that is equals to 2 times sine theta cos theta, right? Whenever you have the sine 2 theta, that's supposed to be this, right? Shall we do a proof? Let's take the easiest one. Let's say the theta to be 45 again. Again, this is valid for any angle, but I'm just taking the 45. So this side I'm gonna have, let's say the left hand side maybe, and then I'm gonna have sine 2 times 45. What's 2 times 45, guys? 2 into 45, that's 90, right? So it is sine 90. What's sine 90? Case 1. I just see if you are looking the table, right? You're supposed to remember those values. Okay, so I'm gonna take the right hand side here. RHS, you know, right? The LHS stands for left hand side, right? Okay, so it is going to be 2 times sine 45 into cos 45. So 2 into sine 45 is 1 over root 2. Cos 45 is also 1 over root 2. So 1 over root 2 into 1 over root 2. Root 2 will be root 2 squared, and that will be just half, right? So 2 into half, and that cancels off. We're going to have the 1. So left hand side we're going to have the 1. Right hand side also we're going to have the 1. And again, this is true for any angle. I have just taken the 45 to be kind of easier. So that's the next trigonometric identity you're supposed to remember. Okay, so with that said, we're going to have this entire thing to be what? 1. Then I could write r squared equals p squared plus q squared plus q squared into 1, so just q squared plus 2pq cos theta. So this gives the magnitude of two vectors, where p is the first vector, q is the next vector, which is kind of inclined here like this, okay? And 2pq cos theta. Cos theta means the angle of the inclination of the second vector. Got it? That's how you do the proof. And guys, this is the same equation we are going to learn for the next one, which is for the parallelogram law of vector addition. Right? We'll do the proof now. Yeah, afterward you can take the square root, which is going to be the square root of the entire thing. I've just kept it like this in case you can remember it very well, right? You're supposed to, yeah, exactly, you're supposed to take the square root of this to begin again in the R. Yeah, you can just gauge it afterward. You can maybe write it somewhere else. Then R equals square root g squared plus q squared plus 2vq cos theta. I'm really sorry for my poor space management, right? This has to be written underneath that. Where it starts all the way from here, right? Here, then after this, then after this, then there. These are trigonometric identities. I'm going to be a side note for you. So luckily guys, uh, up to maybe the very last exam from maybe 90s, they haven't asked to prove this one, like get an equation in the A-level exams. But it's better you're supposed to know how we do this proof, right? It's not much, right? Mm. So we are not going to do a question from this one, I mean an example question from this, because we are moving to the next method, the second method, and it's the same derivation, same equation comes, and thereafter we'll do some questions, right? And since we have finished this one, we'll move into the second method of vector addition, and that is the parallelogram law of vector addition. Now we'll come to the theory, right? First we have written the vector triangles. Second one going to be the parallelogram law of vector addition. We write 2 and we'll just write parallelogram law of vector addition. Okay. Now we are going to write the definition straight away, right? How we can define the parallelogram law of vector addition. We write like this. Before that, guys, for how many vectors we can use this one? Only for 2 vectors. Either the triangle law or the parallelogram law that we are going to consider can be applied for only 2 vectors, right? Okay, so we write when the two given vectors are represented as two adjacent sides of a parallelogram, that can construct using the two vectors the resultant is given by the diagonal of the parallelogram with its length given the magnitude with its length given the magnitude and the inclination gives the direction and the inclination gives the direction. Okay, so what is a parallelogram, guys? How many sides are there? 4 sides. Okay, So can you remember the conditions when it comes to a parallelogram? What about the sides? Okay, yeah. Opposite sides parallel and equal. Opposite angles are equal. Okay, yeah. Diagonal bisects the angle at the vertex. Okay, yeah, yeah. Diagonals will be bisect if the both opposite sides going to be equal, right? Otherwise, if two sides are equal but four sides are parallel, then they are not going to be the angles going to not going to bisect, right? Likewise, I think for the O-level maths, you have learned about drawing the parallelograms and proving a certain quadrilateral to be a parallelogram. Quadrilateral means any shape that is having four sides, right? Okay, so we are not going to dive in detail about that one. We just need to construct a parallelogram here using the two given vectors. So this and this, let's say the two vectors that we have given. And we supposed to show them as two sides of a parallelogram, which means if you draw the P like this, we are not drawing the Q to be at the end point. If you need to construct a parallelogram and showing these vectors are the two sides, two adjacent sides, we're gonna construct the Q to be here, like that. And what's the inclination between the P and Q? Here, for this one, the inclination for the Q is given to the horizontal. From the horizontal, how much it has been inclined. Right? So this is the theta then, guys. Well, do you see a parallelogram here? No, right? Just two sides. So we should construct a parallelogram. How we do that? Well, I suppose to draw a line that is equal in magnitude or equal in length and also parallel to this P and here, like that. So this is also P. And I suppose to draw another Q which is equal in length, also parallel to the Q and here, right? Which is this. And that is also the same Q. If you can remember, guys, I have drawn this one to be parallel with this and also equal in magnitude. So these two are equal vectors. Can you remember? Last day we have considered if the two vectors has to be equal, they have to be parallel and also equal in magnitude. Right? Okay, so this has to be the Q then. Also, I have drawn P here, that's why I just writing P, where these two are parallel and I have drawn this to be equal. So this again an equal vector with this. Then I could write that is to be also the P. Okay, now we have construct the parallelogram. And what gives the result? The diagonal. What's the diagonal? How do you draw the diagonal? Right, it's this one, right? Starting from here, joining the opposite vertex. This is the diagonal, guys. That I could construct. And it is saying that this gives the resultant. And the length of this diagonal gives the magnitude. And the inclination of the diagonal, which I could write this to be the alpha here maybe. And that gives the direction. Okay, so all you need to do here is whenever you have given two vectors, let's say again let me take some counter example. Let's say this is to be 10 newtons maybe, and this to be maybe 4 newtons, and the inclination here is 60 degrees. What do? You're supposed to draw this one again having the 10 newtons, maybe you can use 10 centimeters here. 1 centimeter, 1 newton. So 10 newtons to be 10 centimeters. Here, 4 newtons, you can construct this to be with 4 centimeters. We're supposed to have a protector here to measure the 60-degree as well. And I think you know how to copy the line here, the incline or the angle here, right? Put in the compass, you can mark this and like that, right? Anyhow, you're supposed to draw a parallel line for the 10 Newton that we have written, or maybe the 10 centimeter line that we have drawn. This is supposed to be again 10 centimeters there, right? And parallel with this one. And this you have drawn with the 4 centimeter representing 4 newtons. You're supposed to draw another 4 centimeter line that is kind of parallel with the cube, right? And you construct the parallelogram and you construct the diagonal here, and thereafter you can keep the ruler and measure the length of this diagonal. That's supposed to give what? The magnitude of these two vectors. Let's say, for an example, you have obtained here to be 12 centimeters. I'm just saying, right? So what should be the resultant then? You have drawn each centimeter representing 1 Newton. So if you have 12 centimeters, you're going to have 12 newtons. So the resultant, I'm just saying again, right? This may not be 12, but it will be 12 newtons here. Also, since you have the protector to measure this angle, you can keep the same protector here and find out the inclination too, right? That's how you find out the resultant. Again, when in the exam, or maybe like, let's say you are drawing this one, involving some errors, right? Because let's say this, the construction of these parallel lines will be slightly different, or maybe there's an error in the measuring instruments as well, right? You know. So in that case, the resultant will be slightly a lesser value than the actual one. So it's better we could stick with a certain geometric equation that we can use. So it's a matter of substituting, right? Okay. So let's try to derive a certain equation to get the length of this r again. I think you quite okay with the story here. All you need to do is measuring the length of the diagonal, but measuring it will be some sort of hard to do. Instead, if you can prove a certain equation, you can just substitute there. So to do anything at all, we're supposed to have a right angle triangle. Again, I'm going to construct one. So let's say I'm going to construct it like here, and let me show the construction with again a black color pen. Like that, right? Okay, so we can have right angle here. What can you say about this angle right here, guys? Which? Alpha, theta. Why is it so? Yeah, these are two parallel lines that we have drawn, and this is the shape of F. So these are corresponding, right? Okay, great. Now I can put again Y here, and I can put X here. And I can name this one maybe A, B, C, D, and E. Okay. Then, similar to the previous one, all I could do here is considering BEC triangle, this little triangle here, I could write again X to be cos theta, right? So cos theta equals Q over X. Oops, it's X over Q. So this to be the Q cos theta. Don't mess up with the Q and the theta, right? This is Q, this is theta, right? Great. Again, I can write the sine theta. You know the drill, right? It's y over q, so it's y equals q sine theta. Okay, so I'm gonna put them here. This to be q sine theta, and this to be the q cos theta. I told you, once you do this proof, it's going to be same as earlier. I mean, it will be helpful for proving this. Now I can have another triangle which is involving with the R as the hypotenuse. I could consider A, C, E triangle. And I can consider the Pythagoras theorem once again. And that is going to be AC squared equals AE squared and CE squared. This gives the AB plus the BE and the CE. That's the difference. And the rest of the proof will be like this. Okay? So are we supposed to write it once again? Yeah, it's good. Right? So apart from that, guys, the earlier equation we have derived only for getting the magnitude. If you can remember, we get this one, right? And this is also same equation you're supposed to remember, right? Without having the square root, you're going to have r squared equals p squared plus q squared plus 2pq cos theta, right? And we didn't mention about the direction, right? It's not fair if you don't mark the direction because it's a vector, the resultant. So you're supposed to tell the alpha too. Again, we can do something like this. Do you know that another trigonometric identity is there? If you just divide sine theta by cos theta, what's you gonna have? That's tan theta, right? Oh, that's good. Uh, well, you're supposed to kind of use that one too. In here, you can consider the same AEC triangle, the same AEC triangle, AEC, ACE, okay, whatever triangle. If I consider about this alpha right here, alpha, what are the trigonometric ratios I could write? Think about this triangle and the alpha. I could write the sine with this y to be the opposite side and r to be the hypotenuse, right? And also the cos, which will be this side to be the adjacent side and r to be the hypotenuse. When you write the sine and cos, we should take the r value here, the resultant. It's something that you have calculated from here, right? Not to be happen, but there are the bad days, right? Sometimes your calculation might be wrong. In that case, you're gonna have a wrong answer for the r. And if you substitute that to here to find the angle, you're getting a wrong answer for the angle as well, right? But if you can, this is kind of like a wise advice, I mean, right? So whenever you can play with only the data instead of getting the answers involving that you have obtained, better your the final answer going to be much correct, right? අපි අර data use කරලා ගත්ත answer එක තමයි ගොඩක් correct වෙන දින probability එක වැඩි rather than you just using some calculated values, right? So you can stick with the data, which means we can consider this side, which you can have with q cos sine theta, and the other side here, right, ae sine, which are the values that you haven't involved with the resultant. So what's the ratio that I could write with this and this? Tan, yes. So I could write then tan alpha equals, how do you usually write it? Opposite side, which is CE, over the adjacent side, that's the AE. Well, it is CE. AE is something with AB plus BE, right? Okay, so that's tan alpha. Tan alpha equals CE, that is Q sine theta over AB P plus Q cos theta. Right? If you need to take the inclination, you should take the tan inverse. But we are just remembering it like this. How to remember it? Well, it's pretty easy. You can write the tan alpha or tan theta, whatever, to be sine over cos now. So here also we're going to have the sine over cos. But we're going to have some additional terms here, right? Here the q is the vector that is inclined. q එක තමයි මුලින්ම තිබ්බ inclined vector. So for the sine theta and cos theta, you're going to put the q in front. And plus, we're going to have the p for the denominator. You can remember it like that. It's just sine theta over cos theta, but the inclined one, which is q sine theta over q cos theta, plus we're going to have the p for the denominator additionally. That's how you remember it. Okay. We'll construct the parallelogram and write all these stuffs once again. I guess you have written this one, right? Okay, great. Erase that one. Well, if you need, you can maybe write this one, how we construct the parallelogram line and how we get this triangle. Maybe you can write, produce the AB to E such that the perpendicular drawn from C meets the AB at E, the way that you have written for the O-level. Starting from these two vectors, okay guys? And if there's anything you need, you can try it, right? A whole bunch of stuff. See, even a matchstick name printed yours. You need something? It's a sharpener, eraser, or maybe a pencil. What do you need? A compass. Oh, that I think hard to find here. In case if you need to cut the nails, I just do have a nail cutter too, right? These all are like abundant ones from the students. But it's totally fine. You don't need to draw a perfect parallel line, right? You can use the help of the rules that you have. Make sure you draw the two vectors and the angle in one color and all the other construction in other color, so that maybe later on you can just mark with the pen. මේ අර අපි දීලා තියෙන vectors color එකකින් අනින් constructions තව color එකකින් අනින් resultant එක red color එකකින් වගේ මොකක් හරි color එකකින් අනින්. Maybe you can draw all them in a pencil and thereafter you can shade it, whatever. And again, guys, it's better you could just draw this proof without looking at the board, right? Good for your logical thinking. Alright guys, so I guess now we are pretty confident with this one. So why not we try some example questions, right? So let's come to the tune. And page 1, question 5. And we're gonna do some couple of sub questions there. Let's try with the first one. You can write maybe tude, Q5, and part 1. Okay, so the questions that we are trying in the class with the tude, you can maybe write in the notebook as well if you need, right? I mean, I asked you, I guess, to use 2 books or maybe any other piece of sheets to do the questions in the tude and a separate book to write the notes. But the questions that we are discussing within the class from the tude, you can maybe write it the same notebook in case you can refer it once again, right? You know that we have done that one in the class. I'm just saying, yeah, try the first one. Now, instead of constructing a parallelogram, all we need to do here is substitute into this equation. I see that you guys are always referring to that chart. Make sure you just remember it, right, guys? The angle values. Wait. This is 5, this is 9, okay. 2 into 5 into 9 cos theta. Theta is what here? 60. So it is cos 60. Oh, you ended up with a decimal, right? I'm just wondering why you have taken 2 here. It's 45, right? Okay. Okay, 45, then 151 root. Okay, okay. So yeah, you're supposed to get r equals 151 root, I guess. Okay, good. Well, yeah, you can use the log later on, but don't worry, I can just leave it like that with the square root, right? So yeah, let me do the substitution for you guys very soon. Oh, what is that? This one. So r squared is the thing we should find out, equals p squared, that is 5 squared, and this is 9 squared plus 2, 5 into 9 cos 60. So that is equals to 25 plus 81 plus 2 into 45 into cos 60 is half. So this cancels off, and okay, so we're gonna have 70 and yeah, 151. That's r squared, so r is going to be square root 151. That's in the magnitude, or you can find the direction also substituting with the tan alpha. But here it is asking just the unknown parameter. Shall we write? Shall we find it for the alpha as well? For the first question also, we'll just find the alpha too, tan alpha. මේකට විතරක් හොයන්නකෝ, අනිත් ඒවාට අහන්නේ නැහැ. To get the practice. Q sin theta over P plus Q cos theta, no? We can take the Q to be the inclined one here. So it is 9 sin 60 over 5 plus 9 cos 60. Then 9 into sin 60 is root 3 over 2 divided by 5 plus 9 into cos 60 is half. Okay, so it's 9 over root 3 over 5 into 2 plus 9. So alpha is equal to tan inverse 9 root 3 over 19. Just leave it there. Well, if you're wondering what I did here, I have taken the common denominator to be the 2. So I should multiply the 5 by 2, and that 2, this 2 cancels off. So 5 into 2 is 10, 10 plus 9 is 19. It's okay, you can simplify it any way you like, but more preferably without the decimals, right? If you have finished that one, you can maybe try the fifth one. I mean, fifth part of the fifth question. Fifth question, fifth part. Then what you get? Well, if you divide this one by මේක අපි 40කින් බෙදුවහම මේකත් බෙදන්න ඕනේ. Both side මේ පැත්තම නේද divide කරලා තියෙන්නේ 40 වලින්. So yeah, this side is okay, but you can't just cancel off this 40 only because we're gonna have the addition in between. මෙහෙම තිබ්බහම 6 plus 5 into 2 divided by 2. And you cancel off like this. බලන්නකෝ එන answer එක මොකක්ද? එහෙම make simplified කරලා තියෙන්නේ 17 divided by 2. That is given 8.5. I think you all are stuck here. No. At least you have taken p squared, and there will be a 40p somewhere, right? And there has to be the 40 squared, and you might be ended up with this equation at the very end. Is it? Well, how to simplify this one even further? You're supposed to get the value of the p. Yes. So it's like a quadratic equation, guys. So all you need to do here is factorize. How do we do the factorization? I mean, let's say, we'll take a certain example. Okay, x squared minus 4x plus, oh sorry, yeah, minus 12. Yep. How do you factorize this? So you're gonna take this one to this one, right? That's why you have came to the A levels, right? Because you have passed the O levels, so we should supposed to know the O level knowledge, right? Yeah, so we're gonna have 12 squared here, and we're gonna see what are the factors for this 12. And we should make the middle term. How do you do it? Tell me the factor of 12. 12 into 1, obviously. Yeah. 6 into 2. 4 into 3. Okay. Out of these guys, we're supposed to make minus 4 as well and minus 12. What's the factor you should take? Second one, which is to be the minus and which is to be the plus then? This is minus and this is plus. Good. So x squared minus 6x plus 2x minus 12 equals 0. Then we are taking the common factor out, x minus 6 plus 2, x minus 6. So we're going to put the two terms which are outside the house to be to a one house or maybe one bracket. And these are already within a bracket, so it is like this, and 0. Then what do you write? X equals minus 2. Oh, x equals 6. Similarly, try to factorize this. can okay, p is minus means it's supposed to be to the other side, but we are not taking the minus value there. We can just leave it with the positive value, which is the 40. What are the factors you got? Minus 80p plus 80 minus 40, no? Okay, minus 3 there equals 0. So I can take the p out here. That's p plus 80. I should somehow make the p plus 80 on the other side as well, right? And I can take minus 40 out. It's 0. So p minus 40, p plus 80, that is equal to 0. So p equals 40 or p equals minus 80. So these are the two solutions that we can have here. For these equations, guys, if you substitute the 40 for the p, then you're going to get like this. Or maybe for the minus 82, right? But if you can remember, we are substituting here the values, right? It is a vector, yeah, fine. But when you are substituting to here, guys, we are not interested with the direction. We have only substitute the value there. If it is 10 newtons, we are drawing a 10 newton 10 centimeter line. That's it. So we are not indicating it to be minus or plus. So therefore I could write, since the p has to be positive, p is positive, this is means that p is positive, right? We could write p equals 40. Or within brackets you can write p cannot be negative. Cannot be negative since only the magnitudes are considered. Shall we try the seventh one then? Seventh part, right? Seventh part of the fifth question. Seventh one going to be very easy since you're going to have the theta to be 90. Why I say 7? Because cos 90 is going to be 0. So if this becomes 0, the entire term gets 0, right? So we're gonna have here then q squared equals 130 squared minus 120 squared. 120, right? Yeah. So how do you simplify this? We just find out the square of this and the square of this and take the subtraction. I can do it like that, or else, does this rings a bell? Yeah, these are difference of two perfect squares, so it is going to be a plus b, a minus b. Easy peasy, right? So it is 130 plus 120 into 130 minus 120, which is 10 here. And all you need to do is just add this one and multiply by the 10. Easy, right? Okay. That to be 0 and 5, 250. And yeah, I'm supposed to find the q, not the q squared. I'm gonna take the root. I'm gonna write like this one, like that. You know, the best way to escape out from a square root is make a perfect square inside. So I'm gonna have here, this is to be 5 squared, and this is 10 squared. Voila. So it's 5 into 10, 50. Is it newtons or not? Just this. Hmm. So you're gonna have 144, two zeros. 169, two zeros, zeros. Well, we can do that like this. 30, 130 කියන්නේ 30 into 10 square කරන්න. So 13 square, 10 square. 169 into 100. Well, take the easiest approach, guys, to simplify, right? Saves the time. It feels like things are getting harder now. Well, it's just the beginning, guys. I'm not trying to scare you, but things are going to be a little messy afterward. In future lessons. Right? We're going to try one more, and that is the 10th part. Same fifth question, 10th part. We are just trying this one because each of these are involving with a different aspect, right? 10th part, and that's all we're gonna do. equals cos theta. So theta equals cos inverse half. Theta equals 60, not cos theta equals 60. ඔක හරි ඊළඟ ස්ටෙප් එක ගන්න මේක කපල් නෑ ඊට යට ස්ටෙප් theta කියන්නේ cos inverse half no inverse cos inverse අර minus 1 එක තමයි ඔක එක okay theta 60 no miss about that so r squared equals p squared plus q squared plus 2pt cos theta so it's 40 root 3 squared it's equals to 40 squared plus 40 squared 2 times 40 into 40 into cos theta. So you guys see how lucky in this question. So this 40 squared, 40 squared, 40 squared, 40 squared cancels off. So we can have just 3 here. That's 1 plus 1 plus 2 cos theta. 1 plus 1, 2. That's 1 equals 2 cos theta. Cos theta equals half. Theta equals cosinus half. I like that. 40 squared. So we're going to have here 40 squared, root 3 squared, that is 3. Here also we're going to have 40 squared. Here also 40 squared. 40 into 40 is also 40 squared. I can maybe take the 40 squared out from this side, and that is kind of common with this. So let's cancel it out. Take the easiest approach, guys. You are not provided much more marks when you do the hardest way, right? It's okay, anyhow you can take the answer, but it's just like not like a marathon, right? It's like 100x4 relay. You should run fast, also you should follow some techniques, because it's a matter of time and getting the correct answer in the exams. Both you need to do. Sometimes you can get the answer spending too much of time, that also don't work, because you need to struggle with the time, right? Anyhow, just simplify and you get it like that. Okay, great. I guess that's pretty much it. We have tried many questions, right, related to this one. We're gonna have that little break now. It's 10:33. Have a 10-minute break. So just come by 10:43, and we're going to be doing one question related to this one. And if you have given, you can turn to the other page of the tute. Since you have the tute open, go to the page 2 and see the question 19. 8 velocity vectors. So we have 8 there, right? And if you see the page 3, question 27, you're gonna have like bunch of vectors, like the legs of spider, right? So in those cases, we supposed to know how we get the resultant, where we can't use this method because these are just limited for only 2 vectors. Now we are switching to the next method then, the third one and the fourth one after the break. See you very soon. Now it's 10:34. You can have additional 2. Oh, that's 2 plus 2 here, which is, sorry, 1 plus 1, 2. 2 goes to the other side. 3 minus 2, 1. I have done all things, like that, right? we're gonna be trying one question to kind of summarize this one. So we'll see the 15th question on the page 2. 15 on page 2. We'll try now. So it is saying acting at an angle cos inverse some value. So the angle is cos inverse. What's the value? It's 13 over 35. Isn't it? Which means, should we need to find the angle? No, because cos theta then going to be equal to 13 over 35. Right? So we're supposed to get the cos theta now, p plus q, p squared plus q squared plus 2pq cos theta now. For the cos theta you can put 13 over 35. That's it. Is it 100 and r equals 10? Okay, great. So I think now we are ready to move into the third way of adding the vectors. And before the break, I have shown you there are some scenarios we need to involve with multiple vectors, not just two, right? In that case, we're supposed to know how we can do the addition between those vectors. So we write the third method, and that is by resolving, isn't it? Third method, yes. We write 3 by resolving. Okay, so we write a little point for that. Resolving of a vector, resolving of a vector is the splitting the effect of the given vector, splitting the effect of a given vector to two to two known perpendicular directions. To two known perpendicular directions, right? So let's say we're gonna have a vector like this. Let's say it is to be the vector p, and it is inclined to an angle theta here. So can you guys tell whether it's a horizontal vector or a vertical vector? It's neither a pure horizontal one nor a vertical one, right? So it's kind of an inclined one. So we can't say that it is a vertical vector or a horizontal vector here. Right? So all what we are going to do here is like split this one, or kind of like extract this one, the given vector, considering the effect to two non-perpendicular directions. So usually we're gonna take the two non-perpendicular directions to be the horizontal and the vertical. Right? You're gonna see here, guys, there's a vector here that is kind of inclined, which means there has to be an effect to the horizontal direction. Also, there has to be effect to the vertical direction. Right? For an example, if I just show you with this box right here, let's say this box, right, right here, and I can maybe apply a force like this to this side, not to be horizontal, which is just pushing the box forward, neither to the vertical, which I'm just pressing the box down, right? If I just apply a force downwards, I'm gonna press the box downwards. If I just apply it horizontally, it's gonna move forward, right? But if I just apply the force kind of inclined like this, I'm trying to make the box going forward. Also, I'm just pressing it down too. You can see that the box is kind of deforming when I apply this force, right? Because I'm just trying to push it downwards. Also, at the meantime, I'm just letting it to go forward too, right? If it is just a vertical force, it will be crushing the box down. If it's a horizontal force, it will be just moving forward. But you can see here, if I incline, both of the things going to happen, right? Moves forward, also it pushes down. Which means, if there's an inclined force, I can split the effect to two perpendicular directions, right? Here we are always taking it to be horizontal and vertical. how we can split this effect of this vector into the two. For that one, we need to have a torch. So let's see, torch. Okay, I'm gonna have a torch from my flasher, and let's say this is the vector that is given like this. Okay. Let me do it somewhat larger. To make the exact length. Okay, fine. Great. Like that. So this is having the exact size of this rod here, right? Then what I'm going to do here is, in order to find the horizontal effect, maybe I can construct a little triangle like this, right? And I can put here x, and I can put here the y. Usually we're going to put capital X and capital Y there. So in order to find the horizontal effect, it's like a shining of this torch over this rod, guys. Right? Do you see a shadow? If I just look like this, you can see a shadow, right? Similarly, I can just place it inclined with the exact inclination that I have shown there, right? This inclination, I can maybe place the torch like this. Do you see that there's a shadow? So if I just place it very top to this one, shadow ka pena loud hari pena ne? Right, okay. What may be the size of that shadow? යාට තියෙන shadow එකේ size එක මොකක් වෙයිද? මේ හරියට මම vertically මෙහෙම ඇල්ලුවා. Which means the size of this one, right? මේකේ size එක නේද? So all I could do here, okay, so I can place a torch like this. So the shadow of this vector, or the whatever the rod here, will be falling down, and this could be the length of that shadow, right? Where you could write that one to be simple. I could take this triangle. What's the ratio, trigonometric ratio I could write? With this x and the p and the theta? Cos, yes. So I could write cos theta here, which is equals to x over the p. So x I could write then p cos theta, right? Also, if I need to take this effect right here, what I should do, let's say this is the inclination, and I should have the torch to be pointed as the torch. Earlier it was here. Oh, sorry. Flasher. Okay, guys. So all you need to do here is keep it like this and hold the torch like that. You're gonna see a shadow there, right, on the wall, right? Similar to that, I can place a torch up front like this, like that, and the shadow of it going to fall to a vertical wall if there is, like this, right? And this is to be, I can take it as the y, which you're gonna get with the similar size of this triangle here. This is also y, so as this, right? How do you write the y here? With the p, theta and the y, p, theta and the y. For this theta, yeah, the y is the opposite side and the p is the hypotenuse. So I could write the sine theta equals to y over p. So y here is going to be equals to p sine theta. Which means if you have a vector that is kind of inclined, all you could do here is split this one to two directions, right? Why we do it, by the way? Well, let's say we have to add this with another vector that is horizontal, like this. So can you just add it directly? No, right? Or maybe you could have another vector that is like this with 4 and 60. So you should add this one, maybe let this is to be 10 and 30. I'm just saying, right? How do we add all these three vectors? This is horizontal, that's fine. But these are kind of inclined. But I could take the net horizontal effect of all these forces. Here it is going to be then 10 and goes around, and you can find out this to be the x. Plus, you can add this 12 plus the horizontal component of horizontal, whatever the thing, right, the horizontal effect of this 4. Right? Likewise, all I'm going to do here is split a given vector if it is inclined to two directions and find out the effect to each direction, and I can add the effect to one direction and I can add the effect to the other direction because they are going to be purely horizontal or purely vertical. But in this case they are inclined. You will see what we are going to do, right? First we'll see what is this resolving, right? So I'm going to have this two things or two values that show in the horizontal effect and the vertical effect. Well, there's a posh word that we can use for this effect thing. Actually, it was like slided from my mouth. It is said to be a component. So this is the horizontal component. It's the horizontal component of this vector p, the x here. And this is said to be then the vertical component. Right? And let me mark it specifically with the two colors. This is the x. It's going to be the y. So whenever you have two vectors, you can split it. Or what's the technical term? You can resolve it to two directions which are perpendicular. You can see here the x and y are going to be perpendicular and two non-perpendicular directions. That's why we said, right? Non-perpendicular directions will be the horizontal and the vertical. Right? Basically, you have split it to two directions, and that is the method known as the resolving. Still, we are not found out the resultant of several vectors. We only got to know how we can split a vector, right? So how we just remember it? It's going to be very easy, right? Whenever you have given the vector, listen to this one carefully. Place your arm, whatever the arm, towards the vector. Now this is the vector, right? The P, and you're gonna make your arm, pointing your arm towards the vector. And where's the theta here? This one, right? Just bend your arm towards the angle, and that is cos. P cos theta, which is the x. Bend your arm away the angle. This is the angle, and you should turn it away, and that's going to be the sine component, P sine theta. Towards the angle cos, P cos theta, away the angle sine, P sine theta. That's how you remember it. Always, don't be shy. Take your arm, bend it towards the angle cos, away the angle sine. Cos ගහ පැත්තට cos, කෝණේ පැත්තට cos. Right? Cos, sine. Towards the angle cos, away the angle sine. Right. That's how you remember it. We'll just draw this one and write the two components. If you are using the same pencil, make sure you just at least highlight this P, the vector P එක ටිකක් bold කරලා අඳින්න. pencil එකම නම් use කරන්න නැත්නම් pens use කරනවා නම් colors දෙකක් වේ use කරන්න. It's better you could just sketch this too. But guys, it's not always the horizontal component going to be cos, right? Things are going to change if this inclination is given to the vertical, which means if the theta is not given to the horizontal, instead if it is given like this, then it is not going to be cos theta. Then the two angles going to flip. But still, the poem I told you going to be working because towards the angle cos, which means in that case the y component is going to be the p cos theta, and away the angle sine. X component is going to be the sine. So don't remember always this is cos and this is sine. It depends on the direction the angle is given, either to the horizontal or to the vertical, right? So you could write that one with a pencil or maybe a pen, right? කෝණේ පැත්තට cos towards the angle cos, away the angle sine. කෝණේ පැත්තට cos, කෝණයෙන් ඉවතට sine. Okay guys, after you finish writing that, let's have the practice to resolve some of the vectors given. Let's say we're going to start with the first one. We'll write an example question like this. Find the horizontal and the vertical component. Find the horizontal and the vertical component of each of the following vectors. Of each of the following vectors. Okay, we'll sketch with the first one. Finish the first one and move into the second one. Horizontal component, you can mark it as X, and the vertical component, you can mark it as Y. And guys, you need to mark which direction you're gonna mark it. Well, here the horizontal component is to this side, right? මේ පැත්තට නේද එයාගේ component again. See how you get the horizontal component? Place your arm towards the angle cos. So that will be to this side, right? 50 root 3 වලට අත තියාගන්න. angle එක පැත්තට bend කරන්න. That's the horizontal component. So 50 root 2 cos 45. P cos 45 නේ. ඒක නිසා P cos 45. P sin 45. So 50 root 2 cos 45. 50 root 2 sin 45. That's how it comes. Got it? Simplify it and find the y. Again, place your arm towards the vector, bend it towards the angle cos, away the angle sin. මොනවා issue එකක් තියෙනවා නම් අහන්න. There's the second one, this is the third one, right? I can finish කරලා මේකට එන්න. කමන්න මේක. නිකන් කමන්න. Y component is the vertical one, X is the horizontal one. You should take it like that. Y කියන්නේ vertical. සාමාන්‍යයෙන් අපි Y අර XY plane එකේ Y කියලා ආගෙන ඉන්නේ මේ axis එකට නේද? Y කියන්නේ එතකොට vertical එක ලියන්න ඕනේ. X කියන්නේ horizontal එක ලියන්න. මේකේ XY දෙන්න මාක් කරගන්නකොට ලේසි වගේ. මේකේ Y වෙන්නේ කවුද එතකොට? මේක තමයි Y. x වෙන්නේ කවුද? මේක. මෙයාගේ shadow එක පහළට වැටෙන තැන නේද? මෙන්න මේ හැටි තමයි x වෙන්නේ. මේක තමයි x component එක වෙන්න ඕනේ. මේක තමයි y component එක වෙන්න ඕනේ. y component එක මොකද වෙන්නේ? අර y හැම වෙලේම sin නෙමෙයි. y කියන්නේ මේකනේ. ඒ දෙක මාක් කරගන්න පොඩ්ඩක්. ඔයගේ diagram එක. ඔක y. මේක x වෙන්නේ. දැන් I'll show you this one, right? Always the vertical component is y, horizontal one is the x. But don't remember, I told you, don't remember it, y is always sine, right? Go with the angle. Here I can write the y, which is upwards here. You should mark the direction too, guys. Right? X, y, the direction එක mark කරන්න ඕනේ. කලින් x එක තිබ්බ මෙහෙට මේ එන්න මෙහෙට අනිත් එක උඩට. එකක් මෙහෙට අනිත් එක උඩට. මේකෙත් එහෙමයි. මේකේ y එක තියෙන උඩට. but කොහොමද එන්නේ ඒක? y එක හම්බෙන්නේ 100 towards the angle නේ යන්න වෙන්නේ y හොයන්න. එහෙම නේද? You should place your arm like this and you should bend it towards the angle to find the y component. Yeah, it is going to be cos here then. And that is 100 cos 30. Don't worry, you're going to eventually get to know about this one, right? මේක ගොඩක් practice way ටිකක් අපි ගණන් හදනකොට ඉතින් බය වෙන්න එපා. 100 cos 30. Cos 30 කියන්නේ කීයද? That's why I asked to remember the table. Root 3 over 2. So this cancels off 50. So it is 50 root 3. Leave it like that. You don't need to substitute the root 3 value, right? Then what is x here, which is to this side? Place your arm again. To find the x, where you should bend it? Towards or away? Away the angle. So it is sine. Then it is 100 sine 30. 100 sine 30 is half. Then it is 50. What about this one? Should we need to resolve this? We did the resolving if you have the vector to be inclined, but this is kind of purely vertical. So you can straight away write the y component here is to be the 40. Right? If you are interested in finding the x component, which is going to be like here, this is the x now, could be the x to this side. How do you take it? 40 towards the angle cos what? 90. What's cos 90? Yeah, that's 0. So it's going to be 0. That also gives the answer to be 0, but we don't need to worry about it because it's a perfectly vertical vector. So there won't be a horizontal effect, horizontal component. Only there will be the vertical component, right? Vertical component will be itself the vector. තේරුණා නේද? vertical නේ මේ vector එක. මේකේ horizontal part එකට මොකක්වත් effect එකක් දෙන්න පුළුවන්ද? නෑ. ඒකින්ද horizontal component එකක් නෑ යාට. එහෙම නැත්නම් ඔයාලට හිතන්න පුළුවන් හරි okay fine. කලින් වගේම resolve කරන්න. 40 towards the angle cos 90. cos 90 කියන්නේ 0 නේ. එතකොටත් අපිට 0 කියලා හම්බ වෙනවා. හරි අපි තව කීපයක් කරමු. මම හිතනවා දැන් පොඩ්ඩක් ප්‍රැක්ටිස් වෙන්න කියලා බලලා. අපි තාම මේ වෙක්ටර් සිම්ප්ලිෆයි කරේ නැහැ. හොඳේ අපි මේ කරන්නේ resolving කියන part එක. By resolving we can add and subtract the vectors. Actually add the vectors. Right? තව අපි කීපයක් කරමු. This is the fourth one. හැම එකකම xy mark කරගන්න, right? You can just mark the two components x and y, and afterward you can get it. X will be always the horizontal one, y will be the vertical component. We'll see with this. This is the y, and this is going to be the x. So make sure you just mark the direction where the y acts, guys. So it is y to the upwards here, and that is 200 cos 60. You don't need to mark these two components, but it's better you can mark it too. but highly recommended to mark the direction once you are writing it, right? Drawing an arrow, because these are vectors. So here it is going to be 200. Cos 60 is what? Half. So it is going to be 100 upwards. And here, guys, the x component is to the left side. Earlier case it was all to the right, but now it is to the left side by 200, like that. It's bending to this side, right? And you should mark the direction to this side. X equals 200 away the angle, so it is going to be sine. Towards the angle cos, away the angle sine. So it is sine 60. 200 into root 3 over 200, so it is 100 root 3. Okay, good, great. We'll move to the next one. This, well, same as earlier. This is kind of like a purely horizontal vector. So there will be only a horizontal effect, and that is just 70. To the y direction, upwards or any direction, well, you can take the y if you need and mark it to be 90 degrees. So it is 70 cos 90 again, which is to be 0. Or else, this is the perfectly horizontal one, so why don't we consider this as 0? That's it. Right? Y is 0. We'll move to the next one. We'll first mark the x and y here. Horizontal one will be this, x. And the vertical one will be downwards here. Why? Because if you just bend your arm, it's going to bend like this and to the down. Right? So this x is going to be then to this side, mark it 100 root 3, sorry, 100 root 2. Okay guys, so did I mention it root 2? Okay, fine. Come on then. Root 2 තිබ්බනම් එහෙම තියලා root 3 වගේ දාන්න පුළුවන් මරු. But okay, right? This is cos 30, like that. So it's going to be 100 root 3, root 2 into root 3 over 2. This with 50, root 2 into root 3, that is root 6. So 50 root 6. So for the downwards, that's going to be y down, right? Earlier it was all up, but now it is down. Mark the direction for sure. And that is 100 root 2 into what? 100 root 2 sine, away the angle sine, so it is sine 30. So it is 100 root 2 into sine 30 half, that is 50 root 2. Got it? Great. ඒක crystal clear ද බලන්න මොකද මෙතනින් එහාට තමයි අපිට vectors ගොඩක් දුන්නාම හදාගන්න try කරන්න ඕනේ. Okay? How about you? Done? Okay. This one. Okay? Yeah, sure. So we're gonna have the vector like this. This is the angle given. So I can place my arm, bend it towards the angle, which is gonna give this component, which is the y. Usually the vertical one going to be the y. This is the vertical and this is the horizontal one. So this is going to be the y. So 200. Towards the angle. Here the angle is given 60, so you're gonna bend your arm towards the angle. So y equals 200. That's the p. 200 cos 60. That's this. So to find the x here, the other direction that I need to bend my arm will be to this side, and it's to the left, and this is the horizontal one, so I can mark it as the x. X equals 200 away the angle. Angle is given to this side, right? I'm moving away the angle, so it is sine. towards the angle cos, away the angle sine. So it's 200, away the angle sine 60. 60 here. Right. මට ඒක සමහර මං ස්ටුඩන්ට්ස් දැකලා තියෙනවා දැන් since we are bending it towards this side we supposed to take this to be 30 because entire angle is 90 and you're going to take it to 30. එහෙමත් පුළුවන් but එහෙම හිතන්න එපා. Same angle guys. 69 towards the angle cos 60, away the angle sin 60. Oh, you can think of the way it came from the scratch. අපි මෙතන මොකක්ද කරේ? මේ x component එක ගන්න උඩින් torch එකක් තිබ්බා එහෙම. එහෙමනේ. එතකොට ඒ කියන්නේ මෙන්න මේ shadow එකනේ. මේකනේ යගේ shadow එක. යටින් torch එකක් දැම්මා. මෙතන torch එක දැම්මා shadow එක වැඩන්නේ මේකනේ. පොඩ උඩ ඇන්දලා. It's the same length. Here also the x, here also the x. How do we write the x here? X 200, this x will be the opposite side, right? So it is sine 60 equals opposite side x over the hypotenuse 200. So x is going to be then 200 sine 60. Correct? If you are given a certain angle, you don't need to find the other ones. Like if it is 90 here, then this is 30. It's also fine, but it still gives the same value. So you're going to take it like this, towards the angle cos 60, cos away the angle sine, the same value, same angle, right? Cos 60, sine 60. This one. Yeah, it is straight to this side. So to this side it is 70. It's horizontal. There's no any vertical component here. Horizontal vectors, you don't need to take the vertical component because there's no vertical effect either to the upwards or to the downwards. Got it? Just 70 to this side. That's it. Yeah. So yeah, I could mark it upwards or downwards. That no matter it is to any direction, it is 0. Right? Since there's no any effect to the horizontal, to the vertical. Okay, fine. Are you okay with this one? Okay. I'll maybe give another 2 minutes to absorb this properly, and we'll move into addition of vectors. Okay, all good? Great. Now we write a subtopic. Finding the resultant of a system of vectors. Finding the resultant of a system of vectors by resolving. Finding the resultant of system of vectors by resolving. Okay. Since it's the very first time, we'll deal with just 3 vectors, right? But there could be dozens, like thousands of vectors, yet you can use this method. But let's stick with the 3 vectors first. Let's say I'm going to have 3 vectors, like here, one is 30 degrees inclination, the other one is kind of to this side. maybe a 60-degree inclination. Well, yeah, if the angle has to be proportional, you can just mark with the higher inclination here rather than the 30. And another one here to this side, maybe, yeah, again 30. This is to be 80 root 3, so you should draw the lengthiest line for this one. And this is just 50. And let me take the other one to be 40. So this is, let's say, 60. And that's 40. The shortest line out of these three, right? You know, the length has to be proportional to the magnitude. Okie dokie. So what we gonna do? Can we add them like this? Right? Those are like aligned to almost any direction, right? එක එක පැති වලට මේක incline වෙලා තියෙන්නේ. So can we just add this 40, 50 plus 80 root 3? No, right? You won't be able to. But you can do something like this. So you can find out the net horizontal effect. That means you can resolve all the components to the horizontal direction. And you can resolve all the components to the vertical direction. And if there are the vectors to be like this, tell me, can you add them 10 plus, maybe to this side 5 plus, to this side maybe 20? Can you add them? It's a piece of cake, right? You just add them all. Right here we can have 25, and this is to the other side. 25 minus 10, and that is going to be 15, right? To this side. What if all the vectors are downwards? Maybe like this. Okay, this is 5, and to upwards we're gonna have 30, and downwards up to 10. Okay, then. Yeah, it's going to be 15 upwards, right? I think you get the point. If the vectors are kind of perfectly horizontal, we can add all the horizontal vectors. If those vectors are perfectly vertical, then we can add all the vertical vectors. Right? So all what we are going to do here is split this one as a push word, resolve this each and every vector to the vertical and to the horizontal. And afterward, you can add all the horizontal components and create one vector. And you can add all the vertical vectors and create another vectors. Then your three vectors are going to be just showing two vectors. One is to the horizontal and the other one is to the vertical. Do you know how to get the resultant of two vectors? We do, right? Either the triangle method or maybe the parallelogram law of vector addition. That's what we are going to do. We're gonna simplify this one all the way up to just two vectors, which are one is horizontal, the other one is vertical. For that one, we need to do the resolving. We need to split this one to the two directions. Okay? Great. Now we'll first draw this one and write step 1. Just draw and write step 1. What's the step 1? Yeah, we should resolve the vectors to horizontal and vertical. Step 1, resolve the vectors to the horizontal and vertical. Right? So it's better you could just write the components underneath each and every vector if you have sufficient space below. But not as a not as a rule, right? ඔයාලට මෙහෙම rule එකක් විදිහට කරන්න ඕනේ. මේක අර පළවෙනි question එක නිසා අපි එහෙම කරමු. For the sake of clearance, right? So we'll write all the components of this vector below that. We write the components of the vector here to be down there and this. If you have sufficient space, we'll use it, or maybe you can go to the other page. Alright guys, from here onwards I'm going to use in the blue color, same as earlier. You don't need to, but in case if you are like writing with the colors, that's also you can use. So I'm going to consider the horizontal components. Right. First, the horizontal component. We'll start with this vector. Tell me guys, which direction the horizontal component has to be? To the left or to the right? Place your arm, bend it to the left. Right? So it is x to the left. What's that? 40 cos 60. 40 cos 60. We'll write together. Can you simplify this one even more? Cos 60 is half. So 40 into half, that is 20. Okay, great. We'll move to the next vector, this one. All the figures together. Which direction the horizontal component has to be? To this side, right? Place your arm, bend it towards the angle. You're going to see the effective is to the right side. So it is x again, to the right. What's that? 50, yes. Cos 60. Cos 60 is again getting half. So that is 25. We'll move to the final one. This. Bend it towards the angle. Angle එක මේ පැත්තනේ උඩට නමන්න ඕනේ. So what? To the right side, x to the right, that is 80 root 3 cos 30. What's cos 30, guys? Yeah, root 3 over 2. So that is 40 and root 3 will be just 3 and 40 into 3 will be 120. Okay. Great. Now I'm going to come back and I'm going to find the vertical components. Now we are finished with all the horizontal components, resolving it to the horizontal direction. Let's resolve it to the vertical. Place your arm, bend it away the angle. Which direction it going? Upwards, right? So it is y upwards. How much? 40 sine 60. Away the angle sine. Towards the angle cos, away the angle sine. So it is 40. Yep, we do. What's sine 60? It is processing, I guess. Okay. It's 20 root 3 then. Upwards. We'll move to the next one. If you are pretty confident, you can do the other two as well. Place your arm, move it away the angle. Then again, upwards. So y upwards 50 sine 60. That's 50 into sine 60 again, root 3 over 2. That is 25 root 3. Look at this one. Away the angle, look right to this side, right? It's y downwards now. Nushka, are you okay with that? Y downwards. Okay, great. That is 80 root 3 sine 30. Okay, so it is 80 root 3 sine 30. Okay, half. So that's 40 root 3. Okay, great. Now guys, we're gonna have all the pure horizontal effect of each vector. Also, we're gonna have the pure vertical effect of all these vectors. Now what we can do? Yeah, so these guys are like 20 to this side, 25 to the other side, again 120 to the same side, right? So I can represent this one like this. I'm gonna have an x to this side. Why we say so? Because here this x to this side 20, 20 and this to the 25 and this also to the same side, right? How I'm gonna get the total x? I can write maybe xt. Don't write here, right? This is the step 2. All I can do here is to this side, what I'm gonna have minus 20 plus 25 plus 120. It's okay, you can choose to any direction. If you get it negative, just flip the direction. ඔයාලා අනිත් පැත්තට මෙහෙම මාක් කර ගන්න පුළුවන් අවුලක් නැහැ. එහෙම වුණොත් අපිට ෆයිනල් ආන්සර් එක මයිනස් වුණා ටක් ගාලා ෆ්ලිප් කරගෙන අනිත් පැත්තට. මේ පැත්තට නෙමෙයි තියෙන්නේ නේද? I have already checked that one and I saw that these are two positive and this is the only negative one. So it is to be this side. Okay. Then I can consider the vertical effect too. What's the total vertical effect? I'm going to have upwards 20 root 3, again upwards 25 root 3, downwards 40 root 3. Okay. We think upwards. Upwards. Up here downwards. Okay, fine. We'll take it downwards. I just need to show you. That's what. We're going to have minus 20 root 3 minus 25 root 3 plus 40 root 3. Okay, what we're gonna have there? Because I have marked the y to be downwards. These two are upwards. I'm just taking, right, to show you that. You can mark it to any direction, that's what I'm need to show. Right? You're gonna have it here minus 20 minus 25 means minus 45 root 3 plus 40 root 3. That's going to be minus 5 root 3, right? Okay, minus 40 root 3 minus 40 minus 20 minus 25, that's minus 45 root 3. You can take the root 3 out and add that, right? Very easy. And that is getting added with the 40 root 3, which I'm going to get it to be minus 5 root 3. If you get it minus, that means it's not to the downwards, to the upwards, right? Just flip the direction, no one knows. So it's going to be upwards then. This one, I'm just writing again. That one I'm going to erase this one, that's why. So yt, that's going to be equal to, and this, that's 20 root 3 plus 25 root 3 minus 40 root 3. So I'm going to have what here? 5 root 3 upwards. And here in this case, guys, I'm going to have the yt to be, or just y to be 125. Isn't it? Okay. Now you're going to see the entire effect, or the effect of these three vectors I have just reduced to how many? Just two vectors acting in two directions perpendicular. Okay, that's the step 2. We write step 2. Step 2. Add all the horizontal and vertical components separately. Add all the horizontal and vertical components separately. And reduce the net effect. And reduce R, right? Reduce the net effect of the system of vectors representing two components Okay, now we'll do this. Under that step 2, you don't need to draw these again, you can just draw this sign, right? Just write there the x, and this is the y again. ගෙදර ගිහිල්ලා ආයෙ බලන්න ඕනේ මේක. දැන් අර our brain is not like to keep the things that we kind of push to the brain, right? Brain is always like to remember the sweet memories, not the stressed ones. So your memory going to be eventually fade off, like exponential curve, right? Like this. It's going to be fade off very soon, not like a linear one, right? Within the half hour, right? Just 1 hour, like that, right? Around 1 hour, your memory going to be reduced to below the half even. Check that once you get into a bus and go by 1 hour, and just try to memorize what you have learned in the class. You will kind of not getting anything, or maybe like a little sense. Right? That's why you just need to make it up again, right? Maybe like This is going to work like it's going to be around 24 hours. Right? It's not coming to 0, but somewhere very low value. But you should give another boost here. So it's going to be going like that again. Right? Continuous cycles will keep the memory to be somewhat steady like this in between. Not for the total that we have learned in the class, but not the 0, somewhere in the middle. You can keep it. For that one, you need to revise what we have learned. So I'm just always recommending go home, try the same questions that we have tried in the class first. Take maybe 1 hour or maybe less than that. Try the questions that we have done in the class without looking at the book. And thereafter see the book the way that we have done that. And you can start doing the TUT questions. Got it? Because we know the questions that we have tried in the class has a perfect explanation. So you can have a guidance with that and move to do something by your own, right? Which is the TUT questions. Alright guys, now we have reduced all the effect to just two vectors. How do we find the resultant of two vectors? I'm gonna redraw that one, right? I'm gonna have to this side a certain component x, and I'm gonna have another component which is again the next vector y. How do we do it? Well, you could construct a triangle, or else you can consider the parallelogram law of vector addition, where the resultant has to be lying in the parallelogram that you can construct. Here, the parallelogram will be what? Just a rectangle, right? Rectangle is also a parallelogram, if you can remember. Then, where has to be the resultant? The diagonal, right? It should be going like this. I'll just mark the R like that. How do you find the R? No, nothing fancy. You just need to find R squared equals P squared plus Q squared plus 2PQ cos theta. So P squared plus Q squared plus 2PQ cos theta. Right? In my case, this is R squared, but the P squared here is kind of like the X squared plus Q squared is kind of like the Y squared. Maybe we can interchange these two letters, no issue, right? This to be Y squared plus 2xy cos. What's the angle between these two vectors? 90. Why is it 90? Yeah, because we have split the vector into two non-perpendicular directions. So the angle between the two vectors will be 90. So I'm going to write here 90. Here comes the easy part. What's cos 90? That's 0. It's going to be 0. So r squared is going to be just x squared plus y squared. So r is equal to x squared plus y squared root. So if you know the two perpendicular components, how we can get the resultant then? Just square them, which is you need to square this plus you need to square this and take the square root. That gives the resultant of what? Of all these three vectors. Got it? Great. And not only that, we should tell the inclination to alpha, which you can write here easily, tan alpha. This is y, so as this. This is x. What is that? It's just y over x. So alpha, or you can just leave it like here. But you can take the tan inverse, right? Alpha equals tan inverse y over x. Y, opposite side divided by the x adjacent side. Got it? Great. So we are doing a fair, finding the magnitude, also the direction of the result. That's the step 3. We write step 3. Using the triangle law or parallelogram law of vector addition. Using the triangle law or the parallelogram law of vector addition. Find the resultant of the two components. Find the resultant of the two components. Okay guys, we'll first draw this one and we can get down these equations, and afterward you can move into that one and get the answer. First draw it to this generalized scenario, right? When you can have the x and y, what should happen? Right? Yeah. Is the body shiny? Maybe I can close the curtain. That seems okay. Be specific with the colors. This is x squared. This is y squared. Now you should redraw this one with the resultant that is kind of lying in the middle, R, and just find the R. Yeah, 10 also. Yeah. Are you wondering how this tan alpha came? Which is opposite over the adjacent. For the alpha, C from the alpha, Y is the opposite, X is the adjacent. This. Well, this video will be surely uploaded to YouTube by this coming week. If you find anything difficult, just watch the video once again, right? If you can't do it at all, just watch the video once again. And if you can't do it even like that, you can just ask from your friend. And if not, just come to me straight, right? Just send me a WhatsApp message, so I'll explain it. This now you can do. It's going to be r square, r is equals to 125 squared plus 5 root 3 squared and root. Knowing that 125 is 5 into 25, I'm going to take it like that. Take the 157 root to be 12.53. I just gave this one because this is how the questions have been asked, right? You will not given the root like that, instead like this. Gotcha. Yes, good, great. I said so because, again, the best way to escape out from a square root is making a perfect square. Think whether this is divisible by 4, which you can write 2 squared. That is, right? Yeah. So it is 5 root, this is 4 into 157. So that is, I can take the 2 out. Sorry, square root 4 means 2 into this value. Can you guys see if I just write me? Okay, so it is 10 into root 157 that I have given you. 10 into 12.53. So it's 125.3. That's the resultant. 125.3. Also guys, you're not doing a fair if you don't find the direction of the resultant, which means you should supposed to find the alpha. Mark the alpha in your diagram. You can mark the alpha to the other side as well, but this is the usual convention. And find the tan alpha. That's y over x. Alpha equals tan inverse 5 root 3 divided by 125. You can cancel off with the 5, then root 3 over 25. You can leave it there. When you get time, you can just maybe refer the tan tables. You know the value of the root 3 too, right? You can be very much specific in that case. Got it? That's how we do it, guys. What we do here again, we just resolve all the given vectors to horizontal and the vertical, and you're gonna add all the horizontal components and mark as a single vector. We can add all the vertical components and mark again as a single vector. Now we're gonna reduce, we have reduced the net effect to two directions, two perpendicular directions, finding out the component. And now we are going to merge it back again to show the resultant. Earlier we have split it for each of these cases and found the net components, and then after we're gonna merge back or simplifying the resultant by this equation. Right? And also you can say the angle too. We'll try one question and we'll wind up for today. You can have a little time, so we'll do it fast. Sometimes there are scenarios you are not given the vectors are being individual like this. Instead, you will given the vectors are acting at the same point. I can see in the tute, question 27. We are not going to try the 27th question, but see that you're going to have multiple vectors there acting at the same point, the middle, the midpoint, right? See that? So whenever you are given like that, it's the same principle, guys, right? Same procedure, but you should resolve all the components. I mean, resolve all the vectors and find out the components. Let's try with one example question. We write example 2. Uh, find the resultant of the following vectors. Find the resultant of following vectors acting at a single point. This is 40. We'll go with the Newton. So these are forces, right? Forces are vectors. So this is 50 Newtons. And to this side 20. And to the downwards also 20. Not just that, we're gonna have 20 root 2 acting at an angle 45 degrees. Also we're gonna have another one here, that is 30 root 2 again acting at an angle 45 degrees. Right, guys? So either we can split the, I mean, either we can consider individual vector and find the components and add them separate, like the way that we have done earlier. Or else we can go around and write the net components straight away. Let's just finish drawing this one, and you can join with me and write. Right? Finished? Okay, so I'm gonna take all the x components and I'm gonna consider to this side. You can consider the other side as well, but I'm just going to take it to this side. Right? All the x components, right? And put a dot somewhere or maybe a mark for the starting point. And think about the direction that you go, maybe to the anti-clockwise or maybe to the clockwise. Right? It's okay to any direction you go. Okay, which means I'm gonna start with this. Tell me what we're gonna have here. To this side, we're gonna have 40 straight away. Do we see a component of the 40 or just 40? Just 40, right? Because it is completely horizontal one. We don't have a component there. Okay, done. Plus, moving to the next one. I'm gonna go anti-clockwise, right? To this side. So I'm doing this one in case if you missed one vector, right? Not to happen, right? Miss වෙන්නේ නැති වෙන්න කරන්න තමයි මම මේ එක පැත්තකට consider කරන්නේ. Now we are moving to the next one, 20. මේක erase කරන්න. අර පැටලෙන නිසා. We can have 20 root 2. මේකනේ. That's an inclined vector, so there has to be two components. Then bravely we're gonna place our arm. Then we need to find the x component, so you need to bend it to which direction? I'm interested with this side, so it's going to be 20 root 2 cos 45 towards the angle cos. So it is also to the same direction that I have considered, so it is 20 root 2 cos 45. Right. So I have done this one, and so as this. Move to the next one, 50. Are we going to have a horizontal component? You could have, but it is going to be cos 90. But this is completely vertical, right? So do you need to take it? No. To the horizontal direction, no. So we have passed it. You can put there 0 or just leave it there, right? Moving to the next one, 20. Which direction? To the left side, and it is horizontal. 20 again, purely horizontal vector. We don't have any components. So I should write there minus 20. Why? The direction that I have considered has been marked by this arrow. By this arrow, you are showing yourself and also the one who is marking your paper that you have taken this side is positive. That's all you do by marking the arrow. You have marked this one, so I am considered, right? I've considered this side is positive. Then you can write with words, or else you can just mark with the arrow, right? Positive. That's what we are showing by this thing right here. And you're going to have the 20, and that is minus. Done with that. Moving to the next one. It is also inclined. So we're going to have components. Place your arm. What gives the horizontal component? 30 root 2 to that side. It's going to be the cos component, right? Because we are bending our arm towards the angle. So it's 30 root 2 cos 45. 30 root 2 cos 45. Plus or minus? You can see it is bending to the other side, which is to the left side. But I have considered here that's the right side. So that is again minus. Got it? Moving into this one, 20. That's vertically down, so there's no any horizontal effect. Finish with that. Now I have come to the initial point. Right? Just mark a certain initial point like that, or maybe you can draw arrow, maybe a person like this, whatever, right? Okay, so we'll simplify this one and get the answer to the x components. We'll start. Try your own. First try your own and see the board afterward, right? And in the exams also, you can place your arm like this. Nobody asks, okay, puta, මොකද්ද මේ කරන්නේ? මන්නමක් කරනවද? Not like that, right? Just 10, right? So it is newtons again. It's okay, right? Here they have given the unit, so make sure you just put the units also. Okay, so I have taken this side is positive and the value that I have obtained is also positive, which means the direction that I have considered is okay, right? So this side it is 10, x. Okay. Also, we're gonna find out the vertical components too. Okay, these are horizontal ones. Let's start once again. This griffy right here going to move again to the anti-clockwise direction, and we'll mark y. Very particular. Then start. I'm gonna take it upwards again. That's something that you can choose to any direction, right? Great. Starting now. It's still not 12:30, right? 1 minute left till 12:30. Okay. Starting with the 40. No component. Why? It's horizontal, so there's no component. So this is okay. We have done that. Moving to the next one. You can put here 0 plus or just leave it. Moving to the next one. (20√2) away the angle. You should bend your arm away the angle to make it the vertical, right? Sine. So 20√2 sine 45. Done. Moving to the next one. 50. That's just 50, right? We should take it because it's perfectly vertical and moving up. Finished. Moving to the next one. We don't have any component, the vertical component, because 20 is kind of a horizontal one. Don't get that. Moving to the last one. I mean, there are two, right? Okay, done with this. Moving to the next. We're going to have 30√2. Vertical component goes like this. Away the angle, so it is sine, but downwards, right? It's downwards, so it is minus 30√2 sine 45. Finished with that. Moving to the next one. We're going to have 20. That's perfectly down, vertical, and that is minus. Now simplify that too. So just 20. Okay, 20 newtons and upwards finally, right? It's also to the same direction that I have considered. If you get it minus, mark it to the downwards. So I'm going to have the y to be just 20. So all this effect I have reduced to two perpendicular vectors. Now it's a matter of finding out the resultant. Just draw the resultant and make sure you just draw these two components once again. R. So R is equals to x squared plus y squared root. That is 10 squared plus 20 squared root. That's 10. 1 plus 4. That's 10 root 5. What's root 5, guys? Yeah, 2.24 actually. So 10 into 2.24, that's 22.4 newtons. And mark an alpha. Afterward, you know, right? It's tan alpha equals y over x. Alpha equals tan inverse y20 over x, that is 10. So alpha equals tan inverse 2. Okay, guys, finished? Great. So that's how we do these questions. So we'll mark the homeworks and we'll go fast, right? You're gonna catch a bus, right? Okay, so now you can do the rest of the parts of the question number 5, right? In the first page, question 5, the rest of the parts. We have tried a couple of ones. And now you can try the 6, 7, 8, 9, 10, 11, all those with the parallelogram law of vector addition too. If you can't do it with the triangle law and you couldn't do the other ones, now you can try them, right? Go to the other page. You can try the 11, 12, 13, 14, 15 we tried. Just leave the 16, right? You can try the 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 and 27. I think it's better I just say the questions that you can't do, right? Just the 16th question that you can't do, right? And the MCQs, guys, MCQs, you can try literally all the questions on the page 8. Page 8, all the questions. And page 9, 20. And page 12, all the questions. Page 12, all the questions. And page 13, all the questions. I could say like that. 13, all the questions. Page 13, all the questions. And page 14, all the questions. Just 3 MCQs. Okay, so I guess we'll discuss that one. You're supposed to know these as well, right? So if you can remember, we have considered about few trigonometric identities. One was this sine squared theta plus cos squared theta was equal to 1, right? And also we have considered the next thing which we can later on learn how to apply it, but for the time being we can write sine 2 theta is equal to 2 sine theta cos theta, right? And apart from that, there are some relationships that we could write, and the maths guys know this one. Let's learn them too. So we can later on encounter these things. We're gonna have like sine 90 minus theta and cos 90 minus theta, right? And sine 180 minus theta and cos 180 minus theta. Apart from that, we're gonna have the other values as well, but for the physics we're supposed to know these, right? And speaking of this one, we're supposed to know something called the quadrants, right? Quadrant means like this. Let's say we're gonna have a total circle, and now I have divided equal into 4 segments like this. So we are going to name one half circle here, no half, not half, one quarter circle here to be a quadrant. So this is quadrant, right? Quadrant. So this is said to be the first quadrant, and this is the second quadrant. Alrighty, now this is the first quadrant, this is the second quadrant, third quadrant, and this is to be the fourth quadrant. So a circle has 4 quarter circles, right? Something like that. Let's say you're gonna have a cake and you cut it into 4 pieces, equal pieces, right? Like this. So after you name the quadrants, we're gonna write a little poem, and I'm going to write the Jishnukson's school, right? It is said to be all St. Thomas College, like that. right? So about these guys, so what I have written here is the which trigonometric ratio out of sine, cos and tan are getting positive, right? All means all the sine, cos and the tan, all of them are positive here. In the second quadrant, only the sine gets positive. In the third quadrant, only the tan get positive, which means the other parameter, let's say other trigonometric ratios, the all three ratios will be the sine, cos, tan. No? මේ තුනනේ අපි දන්නේ, right? These are the non-trigonometric ratios. Apart from that, the maths guys know that there are something called cosec, sec, and cot. We don't supposed to remember them, right? We don't need to know about them. So this is how it will be here. Here the cos is positive. That's what it says, right? So just have this one and draw a circle, and you can write like all St. Thomas College, right? And this is going to be the second quadrant. So in the second quadrant, sine is going to be positive. What are the other ratios? Cos and tan, right? They are going to be negative in this quadrant. And in this quadrant, tan is positive. So this is positive. So these have to be negative then. And in the fourth quadrant, cos is positive. So sine and tan is going to be negative, right? You're supposed to know that. Also, we should know how we can write these angles, right? Apart from these two, we supposed to know how to write sine 90 minus and cos 90 minus. Also sine 180 minus and cos 180 minus, right? We'll see carefully what sort of an angle that it says, right? 90 minus means what? This is 90, so we should turn whatever the angle up to 90, and minus means we are at which quadrant? First quadrant, right? Let me show it to you with the stick as well. Okay, starting like this. This to be sine 90 minus theta. 90 has been taken, and minus means we are at the first quadrant, right? Cos 90 minus theta, again 90 minus theta will be at this quadrant, right? Then sine 180 minus theta. What's that? 180 means all the way up to here. Starting from, you should be measuring the angle starting from here and should go all the way 180 minus theta. Which quadrant? Second quadrant, right? Then 180 minus theta will be second quadrant. Okay. The rule here is very simple. I'll write the other ratios as well, right? Sine 90 plus theta also, cos 90 plus theta. This won't encounter much, but it's easy to remember, right? And here it is sine 180 plus theta, cos 180 plus theta, like that, right? Okay, great. So whenever you have, this is the rule guys, whenever you have something with 90 plus or 90 minus, this ratio will be converted into the opposite one. If it is sine, it is converted into cos. If it is cos, it will be converted into sine, right? Here we're going to have sine, it's to be cos then, and cos will be turned into sine, right? So this will be then cos theta. Cos will be turned into sine and sine theta. Removing that 90, you can flip the ratio cos to sine, sine to cos, right? And this is sine, so it is turned into cos theta, and cos is turned into sine theta, right? But we should find what's the quadrant we are now, and we should consider the sign as well. There has to be a minus or plus sign in front. Let's see, right? So sine 90 minus theta means which quadrant are we right now? 90 minus first quadrant. So we're going to have this cos to be then positive. We are not looking at what's the ratio that we got. We are looking at the previous ratio. කලින් හිටපු ratio එක තමයි බලන්නේ. If it is positive in the considered quadrant, whatever the ratio getting after will be positive. Right? We'll try another one. Cos 90 minus theta. 90 minus means 90 minus at the first quadrant, right? Cos is turned into sine and this sine is positive then. Sine 90 plus theta. 90 plus theta. So we are now at the second quadrant, right? So we need to check, should we need to check the sine is positive or the cos is positive there? Yeah, we're supposed to find the sine. We should refer what's the ratio which we were earlier, not the converted one, and think about the sine. Now 90 plus theta is going to be at the second quadrant. So at the second quadrant the sine is positive. So it is positive. And cos 90 plus theta. Again 90 plus theta. That means in the second quadrant we obtain the sine. Sine is positive but we were at the cos, which means that has to be negative. Like that. Okay, let's move to the other one. Whenever you see the 180 plus or 180 minus, the ratio won't change, which means if it is sine, it will be just sine. If it is cos, it will be just cos. And here also it is sine, here also it is cos. Right? And also we need to think of the sine as well. Let's see, 180 minus theta. Which quadrant we are? Second quadrant. Sine is positive or negative? Positive, right? So this is going to be positive. Then the next one. Cos 180 minus theta. We are at the second quadrant. Only sine is positive. Also we need to think of the previous ratio here. The ratio doesn't change. So, but as the practice, think about the previous ratio, right? Not the new ratio that we have converted. Cos 180 minus theta is be in the second quadrant, and second quadrant the cos is negative. We'll move to the next one. Sine 180 plus theta. 180 and plus, which means we are in the third quadrant. So it is going to be only tan is positive, so sine is going to be negative in that case. And cos 180 plus theta, all the way 180 plus theta. Again we are in the third quadrant, only the tan is positive, so this has to be negative. Right? That's how we can take the sign of, the front sign, right? Positive or negative, not the sign, right? The positive or negative sign, actually, how we can get it. Also, when you have 90 plus theta, 90 minus theta, the ratio flips to the other one. When you're going to have 180 plus theta and 180 minus theta, it won't flip, right? It's the same ratio. Without that 180, you can just write as theta. Okay? You can prove this one with the angles, but I'm not going to do it right now. Okay, so we'll copy them down, right? So today we'll need only one of this, just one of this one, I guess. But later on, in the third lesson at the end, we need to know about these again. So there I'll revise you this part, right? Hold on. Table is going up, right? Okay, I guess quite okay. So quadrant and these. You can maybe write with a word. Consider the previous ratio. Okay, great. So you can just write these as well, which are getting negative. Besides, did you write that? Negative and they got liver. Ah, great. Okay. Right then. So now this should ring a bell then for the question 25th. So better you draw them, right? It says that the resultant of two forces P and Q acting at an angle theta is this thing. So let's draw two forces. This is to be P, wherever it is, right? This is to be the Q, and acting at an angle theta. The resultant is given by, where should be the resultant, guys? Is it like to this direction? No, to which direction it has to be? It should be in the middle. Why? Because we supposed to construct that parallelogram, and the resultant is given by the diagonal of that parallelogram, right? Which means the resultant can't lie away from these, between these two forces. The resultant has to be definitely in between the two forces, for sure, right? And that has to be R is equal to, given as like this, 2m plus 1, and we're gonna have p squared plus q squared half power. That means what? Half power means a square root. Yes. So it is p squared plus q squared, like that. Okay. So you can write that one in much convincing way like this. So we know that it has to be a root, right? Otherwise, keeping the half power will be sometimes kind of confusing. Okay. So that's supposed to be the result, and it is saying that when they are acting at an angle 90 minus theta. 90 minus theta means, let's say this angle is 30. Next time the angle is what? 90 minus 30 means 60. So if this is 30, the next angle will be 60. Likewise, they say. So, yeah, I'm going to draw it here. Maybe the other color. The same P and Q, the forces hasn't changed, but the angle between them has changed now, Q. And this is the 90 minus theta. Again, for an account example, if this is 30, this will be 60 then, right? And the resultant now has been changed. The R, maybe R dash, and that is equals to what? 2m minus 1. 2m minus 1 p squared plus q squared root, again half power means root. Okay, great. Now we're supposed to write something with the tan theta. Okay, so seeing at this one should ring a bell for you guys, because we already know how to write the resultant if there are two forces acting with a certain angle. We can either use that triangular law, or maybe you can use the parallelogram law of vector addition. Right? Can you remember that one? Is r squared equals p squared plus q squared plus 2pq cos theta. That's it, right? And we have already given the r, which is this. Earlier we have used this one to find the resultant, but now in this case it is already given. So let's do the substitution. So I'm going to write here. Which color I can use? Okay. 2m plus 1 root p squared plus q squared. The entire thing has to be squared to find the r. And that is equals to p squared q squared plus 2pq cos theta. Right? The angle between them will be theta. Okay, I'm going to erase this one. And let's jump into the other one. Still no clue to write the tan theta, but let's see. Right? So here also I could write r squared equals p squared plus q squared plus 2pq cos theta. Like we just write it as a chanting, and thereafter we'll do the substitution. Now we're going to have the r dash, which is 2m minus 1 into p squared plus q squared, and we're going to have the root square, and that is equal to the same p, same q plus 2pq cos. Now the angle between them is not theta, it is going to be 90 minus theta. I think now you are quite getting a clue with this, right? Because in order to write the tan theta, at least if you know the sine theta, and if you could divide it with the cos theta, that gives the tan theta, right? Lastly, we have considered about it. So we have the cos theta already, but we don't have a sine theta. But we can make one. Here we're gonna have 90 minus theta, which means we add the which quadrant? First quadrant, and it is going to be cos turn into sine, and it is positive. Okay, so I'm gonna replace that again. Before that, I'm going to like simplify this part a little bit and also the other part. Maybe, yeah, we'll finish this part. So it is going to be 2m minus 1 squared p squared plus q squared. The square root cancelled off with the square. That is equals to p squared plus q squared plus 2pq. Now I can write this one to be sine theta. Right? This one also 2m plus 1 squared, and that is p squared plus q squared equals p squared plus q squared plus 2pq cos theta. So in order to get the tan, I should subject the cos theta, and also I should subject the sine theta from these two separate equations, and thereafter I can divide. Now it's up to you again. Give it a try. You can maybe write them side by side so that you can have a good comparison, or maybe one after the other. But we don't know how many steps involving with this, so it's better you just write side by side. No clue so far? Yeah, so you should put a bracket here and expand the brackets afterwards. I have subjected the sine theta and cos theta, but the other side is not looks nice, right? Because we can have this entire thing. I have just taken this p squared to the other side, so it is minus p squared, and this q squared to the other side, so it's minus q squared. Remaining will be 2pq cos theta. And similarly, you can take these the other sides as well. Now, if you just divide this, I could take this equation as the second equation, and maybe this equation as the first equation. And by dividing the second one by the first one, 2pq cancelled off, and we're going to have the sine theta over cos theta if you divide 2 by 1. Okay with that? But the other side here is, guys, not seems to be very nice. It's not the way that it is being required. Yeah, but anyhow, we can simplify it, right? Let's do that. So I'm going to erase the upper part, and I'm going to divide the 2 by 1. Intention of finding the tan theta, I am dividing the 2 by 1, so it is going to be 2pq sine theta divided by 2pq cos theta. That is equals to, I will write the upper part. We're going to have this thing. So it is 2m minus 1 squared p squared plus q squared minus p squared minus q squared. And the below we're going to have this thing. That's 2m plus 1 squared p squared plus q squared minus p squared minus q squared. So you're going to see here the 2 and 2 cancels off, p, q cancels off. So it's going to be sine theta over cos theta. This side is okay. So leaving, right? You can just write as the next step, it is the tan theta. Okay, so we're gonna have this one to be simplified because it is saying that show that the tan theta is equal to some value which is not the way that we have. For that one, we need to like expand this bracket. We're gonna have square term. So let's do it first. How do we expand that? First term squared. 4m squared minus first term into second term into 2. So again 4m. That's 2m minus 1. That's minus 2m into 2. That is minus 4m. And the last term squared. Minus 1 squared going to be plus 1. And the other side we're going to have p squared plus q squared minus p squared minus q squared. Right? So these are like products. Right? We should multiply them, and thereafter we can just cancel off this p squared and p squared, right? Because this is inside a bracket. So as this one, we'll just quickly expand that bracket. 4m squared plus 4m plus 1. And again we're going to have p squared plus. Of course we can't cancel this off, right? Because we have a subtraction here. With the subtraction thing is මේකට මේක cancel කරන්න බෑ හොඳේ. It's like this. 5 into 2 minus 3 minus 7 divide by 3 maybe like 4 into 2 minus 3 minus 7. Can you cancel off this 2 and this 2? No, right? First we need to multiply this one, then you can do the subtraction, and then after you can cancel off. Right? So you can't just cancel this one off because we're gonna have this part right here. So it is minus p squared minus q squared. Well, instead of just dividing it, you can maybe simplify it in this step, right? Then it will be easier if you do it like that. I mean, to be like easier to see, right? In this case, you might be thinking of, okay, these are cancelling. So better you just simplify it for few steps. Maybe you can do the expansion in this step and take the equation 2 to be a little bit simplified version. I could do it like that. Shall I, or I can continue like this? Uh, I think going like this will be okay for me, but if not, again, just simplify this step and maybe write few steps. You're gonna have it simplified, right? Okay, maybe I'll do it like that, right? Otherwise, it's going to be all these divisions. Okay, I'm gonna erase that. It's okay, right? We'll simplify this step, guys. Make a first second kilogram method. We'll simplify it first, and thereafter we'll substitute. Still, the side by side comparison continues, right? I'm gonna write like this then. It is 4m plus 4m, 4m squared minus plus 4m plus 1, p squared plus q squared minus p squared minus q squared, that is equal to 2pq cos theta. And the other side we're gonna have this thing. So it is 4m squared minus 4m plus 1 p squared plus q squared minus p squared minus q squared equals 2pq sine theta. Okay, now we should expand the bracket once again. So I should write with p squared 4m squared minus 4m plus 1, sorry, plus 1 plus q squared 4m squared plus 4m plus 1 minus p squared minus q squared, that is equal to 2pq cos theta. And here I could write p squared 4m squared minus 4m plus 1 plus q squared 4m squared, like p squared the entire thing, q squared the entire thing, right? Minus 4m plus 1 minus p squared minus q squared equals 2pq cos theta. Oh, it's sine theta. Oh, great. My hand hurts too. So let's multiply it even more, right? You can have 4m squared. Okay, so I'm going to do a little trick here. So if I just multiply this one by this, right, you're going to have 4 p squared 4m squared. P squared 4m. P squared plus q squared 4m squared. Q squared 4m. Q squared. And we're going to have minus p squared, which will be cancelling off with this term, right? If you're going to multiply with this p squared with this, that cancels off. And if you're going to multiply with this q squared with 1, we're going to have plus q squared, and we're going to have minus q. And that's supposed to cancel off, right? So I'm omitting one step here and writing directly like this. In that case, I'm going to have 4 p squared 4m squared plus 4m plus q squared 4m squared plus 4m. This minus 1 should be cancelling off. Oh, right? So it is going to be then 2pq cos theta. And I can take you can see it is kind of common for both. So all I have done here is cancelling this thing with the minus p and minus q, right? So you can take the 4m squared out, then 4m squared plus 4m, and it is going to be p squared plus q squared. Also I can take the 4m out, it's going to be m plus 1, p squared plus q squared. 2pq cos theta and 2pq cos theta. Then this I can take as the first equation. Similarly guys, you can simplify this step. It's going to be pretty similar. We're going to have like 4m squared minus 4m, and we're going to have here p squared, and here also we're going to have a q squared, which will be cancelling off with this minus p squared and the minus q squared. Oops, not like that. So it is going to be like this, but cutting will be just not cutting the one, right? Once with the p's, you know, just expanded and I have simplified, right? Alright, එහෙම cut කරන්න බෑ. එකයි p squared කපන්න බෑ. But we're gonna have the p squared in front, which ultimately creates that plus p squared. Okay, then similarly I can write p squared 4m squared minus 4m plus q squared 4m squared minus 4m, and that is equal to 2pq cos theta. Then I can take 4m squared minus 4m out, and it is going to be p squared plus q squared, 2pq sine theta. Okay, so I can take another 4m out again, so it is going to be m minus 1 p squared plus q squared, that's equal to 2pq cos theta. This I can take as the sine theta. This I can take as the second equation. Now let's divide. Now we have like very much simplified equations. So now we can divide the second one by the first one. If you can't see the top step, I'm gonna turn off the light also, and should close the curtain. Got it? As the given? Great. Okay, great. That's how we get it. Well, I know your ultimate question. Will it be asked for an exam? Uh, about that, guys. So surely there won't be essay question asking, but could be an MCQ. Again, not for the very first question. As we have seen in the other papers also, for the MCQs, from the first question to the about the 10th question, it's going to be very easier, right? Because asking some basic things, and from the 11th question to the 20th one, or maybe like 25th one, it's going to be in the medium level, right? And from the 26th to the 26 to the 40th one. It's going to be the hard question. I mean, somewhat takes time, but yet you can do, right? Not much, but you can do them, but take some time. So from 40 to 45, the questions are going to be really tricky, but yet you can do. Takes some more time as well. So 46th one to the 50th one are going to be the extremely hard questions, right? Uh, I mean, so if you're a very talented student, uh, maybe like completing the paper very soon, also like having good marks, maybe going for an A, right? Of course, you're gonna be definitely right. So when you get like we are trying to get an A pass, at least you should be able to read up to 46 question, read and get the answer correctly, right? You're gonna have these last four questions. A super bright can do them. You guys also can. But it's a matter of taking the time until you do this 46 question. They say, all right, now විනාඩි 5යි තියෙන්නේ, right? Like that. Now it's the 2 hours has been finished, like almost has been finished. And at the last question, they say, okay, check with the index numbers has been written, or they are saying that just having 5 minutes and make sure just cross all the questions like that. They are giving instructions as well at the very last minutes, right? At the meantime, you won't be able to like answer those four questions because to read at least one question, it takes a very, I mean, like 2 or 3 minutes to take to read the question, read and understand the question. And sometimes this is not common for all the, I mean, all the papers. If you see the 2023 past paper, which was the recently came the easiest paper out of the papers that we have obtained, right, for a couple of decades. And there, the 50th question is also very easy. But apart from that, the usual structure is going to be from 46 to the 50th question is going to be somewhat taking the time. Not somewhat, actually, it takes quite longer time. Even to configure the question, right? So if you are going for a, not if, right? You should be definitely going for an A for the physics. I mean, for the other subjects too. So at least you will be able to read and correctly answer up to 46 questions. What about the rest of the four? And that's why you need to have this, do the worshipings and everything before the exam, right? You can just worship to your pen and you can just mark them if you don't have the time, right? I'm just saying this one. So you should be confident enough to try all the up to at least, right? At least up to 46 questions. The rest of the four will matters. If you are good enough, if you can manage the time very well and also answer the questions very fast and very well also, right, getting the correct answer, then answering this 50 will be a piece of cake, right? I'm just saying this one. This could be one of the MCQs that will be asking for the questions between the 46 to 50, right? This will be given, and you will be given the some sort of answers like tan theta equals, the first choice is going to be tan theta equals this value and this value, this value, like that. 5 choices will be given, right? So it's nothing but yet you need to simplify a little bit to get the answer accurately, right? So once you get the practice, I think this won't take maybe 2 minutes to do, right? You should write faster and do the simplification. And all you need to see here is the process that we have done. So we started from nowhere actually. We didn't know even write to tan theta. But we drew them and marked the angles and written the two relationships. And thereafter you found a clue to get the tan theta, right? In the cos theta and the sin theta separately, right? That's how you do it, and probably it could be asking for an MCQ, but not for essay question. Mostly, it could be for a term test, but definitely not for the essay exams, right? The A-level exam. Okay, great. Similarly, you can try the 26th question also. I'm not going to do it now, but later, right? Great. So today we are going to finish this unit also. So let's see some more questions whether you have tried them. How about the 26th, 27th one? Didn't try any? Okay. So I think you might didn't have the time to do it. You got the classes last day, right? I'm really sorry. I'm sorry. I'm sorry. So next day I'll try my best to upload it as soon as possible. Okay, so we'll try that. We should have that practice too. So let's try the 27th question, part 3. You don't need to copy it down, but you know the drill, right? Actually, you should pick up a certain starting point, and you should go around, consider each and every vector. Once you consider it, make sure you just put a tick in case if you missed one, right? And by the way, guys, I think the school's gonna start very soon. Because of the, I'm not going to ask your result. I know that you are totally fed up. I know that you guys have a good result, so that's really good. I really appreciate. And since you have passed the that stage, now it's the final stage that you need to finish up before your higher studies. So I'm congratulating you all guys, and the school is going to start very soon, I guess. And I think for you guys it is already started. But since you are applying for the sure you are applying for the centrals, right? How about you? Not the intention of applying for a school? No, I think we'll see about that. Just we'll apply. Yeah, that's also fine. Yeah, we'll apply it. Right? We'll see. If not, we'll just go with the usual procedure, right? Centrals, they're gonna request a huge result. I mean, thereafter they are sorting the process. They might have a chance, right? Surely. So let's apply and see. If not, we'll apply private, right? No hassle. So anyhow, how you guys like? Now we need to shift the class to a weekend then. So the available time slot for us will be the Sunday evening after 1 o'clock. Not possible. Is there? She has recently put it. 1 to 3. How about you? Okay, so that won't go for a while. I mean, okay. How about Sunday morning? Chemistry. So it's on Saturdays then, right? I guess. Here comes the confusing part. Okay, so I thought that I think once let you guys know, right? It's probably on the Sundays. So that thing continues. I mean, for you, the practices. I know. I think no, right? Right. So, is there any clue from the bio? Sir, right? The teacher or sir? You okay? Did he mention? Ah, come in. So, believe us, Tanuji, we were like doing just one question from the morning. It was a very large question actually. We tried the question 25th, right? Uh, okay. Did he mention anything about like shifting the classes after this 2025 finishes? No, he's going to make it fixed. Okay, okay. So how about you, Tanuji? Are you free on Sunday evenings? Not really. So you're gonna have classes too, like one, two, on the same class. How about Saturday evening after 12? So 2026 is there. Oh, the timetable has also been fixed, I guess. But let me see. Let me see. So how about for you? Saturday evening? Great. So I'll ask the 2026 batch whether we could shift the class to Sunday evening. Then in that case, we can apply for the Saturday evening. Okay. So Sunday mornings is not possible, I guess, because there's a class going on here. Yeah. So I'll try my best to put the class in the Saturday evening then. From 1, sorry, 12 to, not 12, 12:30 to 5 o'clock. Then I think it's convenient for you also, right? You can go by Sunday evening then. Yeah, I'll try my best, right? How about the usual classes going on the other institutes? I don't know, like for the physics. Do you know any class that for the English medium? The usual time. Did they mention anything about that? I mean, it's on Fridays. Evening? After school, I guess. Well, arranging a class after school is not that much of good because you feel kind of tired, and even I don't like the evening classes, but what to do, right? At least if it is in the weekends, it will be manageable. Okay, so for the time being, we'll think of the Saturday evenings, right? I'll just let you know, guys, very soon, maybe today evening. If we can arrange the class, we can have the classes on this Saturday too, right? If so, great. So we are moving to the third page, question 27 and the third part. Have you tried it? Okay, why is it so? Didn't have the time. I couldn't do it. Ah, okay. So all of you guys have tried out to there. Okay, okay. Yeah, we'll try the 27th question, part 3. I'm just waiting for you guys to confirm whether the two components are the values that we have done. This is okay, no? X still finding out. Okay. Indeed, 130. Okay, so how about you? X. Okay, okay. Mm, okay. This last one? No, there. Yeah, this one. Sin 30, leave it in it. Ah, make it. Ah, right, right, right. Mm. Is this theoretical? No? 130? It has to be. Yeah. I am lucky. I feel lucky because I got a 90, 196, right? So we're supposed to find the alpha also, which is the inclination here. So it is tan alpha is equals to y over x, that is 30 root 3 over 130. So alpha equals tan inverse root 3 over 13, 3 root 3 over 13. Alright guys, so with that I think we can move into the last part of this one. We have the last, fourth and the last method to add multiple vectors, and that's the drawing of vector polygons. Right? Since we have a little time before the break, right? We'll just try the topic and we'll finish this part off, right? So the next day we're gonna be starting the mechanics, right? And that's kind of like the lengthiest, right? The lengthiest unit in the syllabus, and it will take around 6 months to finish off. So we are starting the first lesson from there, the motion, right? And yeah, the all over parts are there usually in the beginning part, but later on we're gonna deal with some advanced concepts. Okay, so once we finish this one, we write the fourth method, drawing of vector polygons. A topic, right? Drawing of vector polygons, same as you have written the first three. By the way, what was the first three? Yeah, we have first drawn the vector triangles, then yeah, the parallelogram law of vector addition, thereafter by resolving, and this is the fourth one, by drawing vector polygons. And if you can remember, the first two was for just for the two vectors. We can't deal with multiple vectors there. If so, we need to reduce it, right? And to reduce that one, we got to know the resolving method, where we can resolve and reduce the system of vectors only to just two vectors, right? Then we know how to get the resultant out of it. Okay, so here comes the vector polygon, right? So let's say you have given few vectors like A plus the B to this direction plus maybe the C to this side plus the D to this side, and maybe an E here as a shorter one maybe. Let's say we supposed to add all these vectors. So you're gonna see here it is just more than 2 and more specifically we haven't, let's say, given some values here. If so, we can maybe construct something, try to construct a triangle, but triangle has 3 sides. Here we're gonna have several sides. So what does it mean by a polygon? A polygon, it has many edges and many vertices, but it has to be a closed figure, right? Okay, so any enclosed figure with n number of sides is said to be a polygon. Right? So all what we are going to do here is trying to construct a polygon out of these vectors. So let's say, uh, so to draw the polygon, same as the way that you have drawn the vector triangles, we can choose a starting point, and you can first draw the vector A. And at the end, you can draw the vector B, somewhat aligned to this direction, right? I'll draw it somewhat larger. But this line and the line that you are drawing has to be kind of proportional and should be equal if you are drawing the vector A. And the inclination and the line, the length of the line has to be kind of proportional when it comes to this, and this is the B. And thereafter, you're going to have the C to be kind of like there. Let me just flip the direction a little bit so that it will be easy for us. It's going to be the C. So at the end of the vector B, I'm going to draw the vector C to this side. Let's make it somewhat lengthier to distinguish clearly. Okay, like that. And the D is kind of a horizontal vector to this side. This is the D. And thereafter I can just draw that E, which is kind of like a short vector. Means a vector like to this direction, and that is the E. Okay. All what we have done here is drawing the vector one after another and trying to construct an enclosed figure. But you're gonna see here, this is the starting point and this is the ending point. And it is not a polygon because it's not an enclosed figure. To make it enclosed or to make it a closed path, what we should do? We should draw a line that is connecting the starting point and the ending point. And guys, that gives the resultant of this system of vectors. If I just mark it to be A, B, C, D, E and F, I could write like this. The AB vector plus the vector BC plus the vector CD plus DE plus EF. That's going to give the resultant as the vector A to F. Just merging up these letters, you can see here B get merged and C get merged, D get merged and E get merged. So ultimately we're going to have the starting letter and the ending letter, AF. That's how we can construct a vector polygon. In this scenario guys, most of the time if the questions are given, they are not kind of asking a value. Instead, we are supposed to find which direction the resultant vector is aligned. As an example, you can see the MCQ. See the page 9. Page 9. Question 20 starting from 22, right? See the question 24. The resultant of the following vector system is. Just asking, giving the directions, it is asking where the resultant has to be aligned, not with the magnitude, right? So vector polygon method can be mostly used, or questions are being mostly asked, not to find the value or the magnitude. Instead, we have to find just the direction where the final resultant will be aligning. That's all we can do from this vector polygons, and very easy, right? We'll write a little note and thereafter we'll copy this one down. We write like this. A polygon is an enclosed figure. Is an enclosed figure with distinct number of sides. With distinct number of sides. Okay. Drawing, we can write in the next point. Drawing a vector polygon. Drawing a vector polygon is the extended process of drawing a vector triangle. Extended process of drawing a vector triangle, which can be used to find the magnitude and the direction of the resultant. If the vectors are drawn to a scale. If the vectors resultant, magnitude and the direction of the resultant, if the vectors are drawn to a scale. Yeah, sure. From there can be used to find the magnitude and resultant is there. Can be used to find the resultant, the magnitude of the resultant, magnitude and the direction. Sorry. can be used to find out the magnitude and the direction of the resultant. And the direction of the resultant if the vectors are drawn to a scale. Okay, right. So here I told you we can just say the direction where the resultant is aligning, which we here in this case it will be the AN. But you can use this process explicitly to find the actual magnitude and the direction as well. All you need to do here is, let's say if you know uh, the size of the vector or the magnitude of the vector, let's say I'm just taking some count example here, let's say this is 5 newtons and this is to be 4 newtons or maybe like 8 newtons, and this is to be 20 newtons, let's say, for an example again, right? This to be 10 newtons and this is to be just 2 newtons. All you need to do here is, let's say we have 5 newtons, you can maybe represent that with the 5 centimeter line, each newton representing 1 centimeter. And if you know these angles also, let's say this is 30 and this is 60 and maybe to this it is 45, I'm just saying, right? So you can measure up the angles also, like here you're gonna have 30 here and thereafter 60, this is completely flat, and this to be 45, right? Likewise you can just draw this with, this is to be, let's say, 5 centimeter line and this to be the 8 centimeter line representing 8 newtons, this to be 20 centimeter line representing 20 newtons, and so on, right? And if you draw with the proper angle, you can finally measure up the distance between the A and N, and that's supposed to give the magnitude. Let's say again for an example, you got here to be 35 centimeters, so the resultant has to be 35 newtons because we have represented 1 centimeter by 1 newton, right? 1 newton by 1 centimeter, so 35 newtons. And you can even measure up this angle from a protractor, then it gives the direction of the result. Got it? But you know that it's not going to be very much practical when you're doing it in the exam, so most of the time it is not the magnitude that they ask, instead which direction the final resultant has to be lying. That's what it's asking. Okay, so let's write a definition for this polygon uh, polygon method, right? We'll write the definition. If the given vectors are drawn to represent the n side, simple n sides, of a polygon the n plus 1 side, the simple n plus 1 side completing the polygon joining the starting point and the ending point. Joining the starting point and the ending point should give the resultant of the simple n vectors in both magnitude and direction. Okay, which means these are the n vectors You can see here this is the first vector, second, third, fourth and fifth. So there are 5 vectors, and I can draw them to be simple n sides, like 5 sides of that polygon, and we should construct this additional side which is going to be n plus 1 side, right? This is going to be the sixth side. Already we have drawn 5 sides. This is going to be the sixth side, that is we say n plus 1, right? Already 5 plus 1, it is the sixth side. So that should give the resultant in both magnitude and the direction. That's what it says. Okay, we'll just copy this one down, and at the end we'll write like this and should draw that. Alright, so hereafter we are going to try some questions until the end of the class, and we'll see some special questions too and how we can do them. We'll start with a question that for the theory that we have recently considered, and we'll go to the page 9 in the theory. And we'll try the question 23. Okay, so before that, shall we do with the 21? Page 9. Okay, page 9, question 21, we'll first write 21. It's easy peasy. You can say it with his hand. Yep, 21. It has P towards. We're gonna have AC, CA, which direction? 21. Yes, AC, right? Because you can see the vector is starting from A goes to B and from B to C. Then the starting point and the ending point will be A to C, right? AC there. Okay, now about the 23. Yeah. So see carefully there, it's not a closed figure, guys. If it is a closed figure, this should be like going clockwise or anti-clockwise, but it's not. You can see the A to B and B to C vectors are terminating at the C. If it is going from C to D, then it is fine, and D to A, then it is 0. But here it is not. So, well, we know how to merge two vectors, right? You can represent a single vector for 2 here. You're gonna have here A to B and B to C and C to D, like this. You can see it's not going a complete round, but you can do like this. We know that if the vector is starting from A to B and B to C, the resultant will be, for these two vectors, it is going to be the AC, isn't it? So I can remove these two vectors and represent it to be the AC vector. And you're gonna see there's another vector that is going to the A to D and D to C. Then what's the resultant of that? And those have to be also aligning the A to C. I can remove these two vectors too. So what's going to be the resultant then? 2AC. That's how you take it. Good. Uh, let's. Yeah, sure. Take it. Now let's try the 25th one. 25th. Sure, then you don't play here. But සම්මාදම් වෙනවා. ඔව් පොඩි ප්‍රශ්නයක් තියෙනවා සර්. ඒක දැනග එන්නේ නැත්නම් ගන්න එන්න ගන්න පටන් ගන්න හරි ඒක සර් මම දැන් ටිකට ගන්න ප්ලේට් එකක් දීලායි මම ඕන්නම් එන්නම් පොඩ්ඩක් කඩක් කාලයක් අල්ලම වැඩ මම පොඩ්ඩක් කියන්න okay yeah 25 yeah Jishnukshan what you got 25 C I mean fourth one oh kida third one 3AE okay what do you say third one okay yeah it has to be so you're gonna see there if you just see from A to F and F to E this is how we just reduce the vectors right like this and going to be like this so it's from A F E D C B like that yeah we can define a vector resultant for this AF to FE. You can see here it's not a closed figure, right? So AF to FE it is to be like this. I can remove off this one. And you can see from the A it is going from B, C, D and E. Then also I can represent another vector that's also aligning with the AC AE direction. I can remove these parts then. Resultant means the net effect from system of vectors, right? Instead of those, I can represent just one vector here. So you can see there, it is like lining from A to E. So we can have three lines. These two are from the resultant, and this is the vector already there lying into the AE. So it's going to be 3AE. That's how we get it, right? Great. It seems very easy, right? Okay. So how about 29th one then on the other page? What was it? Okay. Let's see. The magnitude and direction of four forces acting on an object are represented at OA, OB, BC, and CD. The equation is, that means the resultant, right? It's supposed to find. Hmm. Okay, let's see. So there we have given the magnitude as well in terms of the piece, and we're supposed to find the resultant. It's going to be, here we're gonna have 10p and this is 6p, like this, and up we can have the 5p, B A B C. Okay, and like this 6P. Great. Yeah, so you can take it to be like this. So I can reduce these two vectors to be going from B to C and C to D to be from A B to D, right? To be from B to D. What's supposed to be the magnitude? You can see here it is clearly being drawn to be matching with the 6P. So this is also 6P then, but the direction is to the other side. uh, then I'm gonna have like from O to A and A to B, it is to be to this side. We don't know what's the value, right? Uh, okay, you can find it from the Pythagoras, but yeah, we'll just leave it like that. And thereafter, it is going from O to B and B to D. That means the final resultant has to be like this, O to D. And it is O to D, and the value here is going to be exactly equal to the 5P, which is the length of the AB line. Right? And it is just 5P OD. ODO. OD, right? Not the OD from the Garfield cartoon, right? Okay, great. Now it's easy, I guess. Now we are going to try some mixed problems. I think this is quite okay, right? Drawing vector polygons and saying the resultant. Okay, great. Now let's see about the question 43, the MCQ 43 on the page 12. MCQ 43 on the page 12. answer. Okay. We'll see, right? So it is saying that there are two forces, maybe let's say P and Q, right? And they have given it to be, one is A plus B, the magnitude of the two vectors are A plus B, and the other one is A minus B. It is asking, okay, for the resultant, which should be, that should be definitely lie in the middle of the two vectors. It can't be to any other direction, right? And the resultant has to be something strange, and that is to be root A squared plus B squared. And for that one, what should be the cosine angle, that means the cos theta, between the two vectors? That should find out. Well, we are not getting panic here. We know to find the resultant of these two vectors, it is going to be r squared equals p squared plus q squared plus 2pq cos theta. So p squared here is going to be not just a single letter, it is going to be a plus b plus q squared going to be a minus b squared plus 2 times a plus b, a minus b cos theta. So we're supposed to find this cos theta, making as the subject later on. And you're gonna see here that is a squared plus b squared root into square, which cancels off the root. So I can write that one in the next step, a squared plus b squared equals. Okay. So we need to kind of like expand the bracket here, so that we can cancel off some a squares and b squares. You're gonna see that it comes from here, right? Let's do. So it's going to be a squared plus 2ab plus b squared, expanding this bracket. And I can expand the other one too. It is a squared minus 2ab plus b squared plus 2 times. Just think, this rings a bell for you? A plus b, a minus b? Yes, it has to be a squared minus b squared. This is like difference of two perfect squares, right? A plus b, a minus b. I could write like that. Why? Well, I can just leave it there for a while, but if you see the answers, when you're trying the MCQs, like always look through the 5 choices. Right? Sometimes you might be simplified after the final decimal, but it is given as just a root, right? So which is a waste of time. So when doing MCQs, always be tallying with the answers that are the choices that are given. So there you're gonna see something with a squared and b squared minus b squared, right? Let's make that one. Okay, so you're gonna see here the a squared cancels off, which means I can take this a squared to the other side, makes it minus, and this cancels off with the a squared, and so as the b squared. And you're gonna see here the plus 2ab there and minus 2ab there, so that also cancels off, and the remaining one will be this. I can take both to the other side because I need to subject the cos theta. Then minus a squared minus b squared equals 2 a squared minus b squared cos theta. Then I can make the cos theta as the subject. Cos theta equals, I can take 1 minus out. It is going to be a squared plus b squared over, oh there's a 2, no, 2 goes down, right? Yeah. So it is a squared minus b squared, and the 2 is there. You're gonna see an answer like that. It's not given like that, right? Because we're gonna have a minus here, so we need to cancel off that minus anyhow. Well, you can do it by multiplying both sides with minus 1, or maybe like here we're gonna have the minus 1 even though we are not writing that, right? I can take 1 minus from this too. It's going to be cos theta is equal to minus 1 a squared plus b squared. It's going to be b squared minus a squared, and I can take minus 1 out from that. Yet it gives the same value. See, it's minus b squared minus into minus plus a squared, and that minus and this minus can be cancelled off. So you're going to have the cos theta to be a squared plus b squared. So we have to have 2 here, right? So it is 2 times b squared minus a squared, which gives us the answer, the second one. I think you got it, right? Second one? Okay, great. That's how we do it. Now the question 53. 53. MCQ 50. Oh. 52. 52. We'll do the 52. Exerted force means the resultant force, right? Just think about it like that. Yep. Okay. What do you think? No clue? Okay, great. We'll see. Well, unlike the other cases, here we haven't given the magnitudes, right, with some values. Instead, in the question it says these are given to a scale, which means all the lines that here is being drawn to a certain corresponding magnitude. Out of them, just see if there are two lines that are equal in length, and if they are aligned to the opposite directions, that's supposed to cancel out. So do you see there the F2 and F6 are kind of having the same size, but they are to the opposite direction? Then that should cancel off, right? F2 and F6 should cancel off. Then what about the F3 and F7? F3 and F7. That means the OE vector, right? not OE actually, F3 and F7. They are purely horizontal, but you're gonna see there the F7 is shorter than the F3, which means there are supposed to be a resultant out of those two vectors F3 and F7, which should be to the right side, right? Not to be having the same F3 size, but a little one. With actually, I can write here F3 minus F5, right? F6 and F3, F2 cancelled off, and you're gonna see there the F4 and F8. They are also kind of to this side, right? Like shape of diagonal. And where should be the resultant? To the downward direction, guys, it is F8 minus F4, right? And you're going to see a similar vector with the F1 and F5, and since the larger vector or the longer vector is there for the F5 side, the F1 side to the downward direction, it's going to be F1 minus F5. F7, sorry, F7, yes, sorry. Great. That's pretty much it, guys, right? So we have kind of simplified our diagram to a little bit. And which direction the resultant has to be? If you consider these two vectors, only these two vectors, the resultant has to be somewhere in the middle, but not exactly in the middle. Could be somewhere, but we are pretty sure that the resultant has to be lying somewhere between the two vectors. That's for sure. Which means we can get the answer to be either it is OA or OC. Sorry, OB or OC. Right? If OB, which means this has to be higher, so it will be kind of going to this side. We know that the resultant is closer to the higher vector, right? If it is OC, that will be kind of going to the other side, right? What about this thing here? You're going to see very little vector that is going to that side. So there's a more likely chance to make the resultant not to be going to this side, to the other side. The question here is whether is it OC or OD. It has to be shifted towards OC or maybe OD. OC is somewhere here, the C, this is O and this is C, and the OD is somewhere here. How do you find it? Well, what I can do here is I can just remove these two vectors, the f1 minus f5 and f8 minus f4, and representing this as their resultant. Right? Could be a little bit to this side or maybe to the other side, but most of the time it could be like line in the middle. How we can guess that? Here you're gonna see that the f1 and f8 lines, f1 the line which was earlier and the f8 line are kind of drawn to the same, isn't it? And similarly you can see the above lines which will be the f4 and the f5 which was to the upward direction, and those lines are also kind of same in the size, right? So we can be kind of have a guess that after we simplify these to these two vectors, like subtracting f4 from the f8 and f5 from the f1, these two vectors are also should be equal. Where we can have a kind of like a good idea that the resultant of these two has to be lying exactly in the middle, right? But we know that that has to be a higher value because these forces are greater than f3 minus f7. So I'm going to remove this force, these two forces, and representing this as their resultant. Now that resultant will be another vector or another force with this one. How we can write the resultant there? Should be again somewhere in the middle, right? But we can see here, guys, the resultant, I mean this force, the red color force will be here is a greater value. So the resultant of these two forces more likely to be bending not towards the smaller vector, towards the larger component, which it's going to be mostly the OC to be the answer. That's how we take it, right? Okay with that? If it is not given the magnitude wise, yet you will be able to find that one out. Alright, so we'll try just few more questions and we can wind up for today. Maybe a little bit earlier, I guess. Let's come to the easy MCQs like page 8. Page 8 and question 14, MCQ 14. Last day I think I have to do them, right? Okay, shall we try it now? Just think about it again. 14. These the choices, the vectors given for the choices could be aligned into any direction, right? ඕනේ direction එකකට තියෙන්න පුළුවන් එක. You could think of what are the ways that we can make the resultant to be 0. The closest approach is going to be from the vector polygons. How the resultant can made to be 0 from a vector polygon? If we could construct a enclosed polygon out of the vectors given. How we can find out whether we could construct a enclosed polygon out of these? Polygon here will be a triangle because we're going to have 3 vectors or 3 sides. Why not the other ones? How about 5? Fifth choice. 5, 5, 5. Can we make it a closed triangle? Yeah, we can. We can give it a special name as well. Equilateral triangle, right? So we can do that. What can you say about the other one? Well, yeah, so there's a little trick here you need to know, and I'm going to teach you now, right? Whenever you are given a question like this, just identify the smallest 2 vectors, right? Out of them, if it is 3, this will be applicable for just 3. Identify the smallest 2 vectors. Let's say we have given like A and B and C. In this case, let's say A is lesser than the B and that is lesser than the C. So we're gonna see here lesser than, this could be lesser than or equal, and the third vector is like that, and that also maybe okay, lesser than or equal, fine. And out of the 3 vectors here, the smallest vectors are going to be then A and B, right? C is the greatest one. And check whether, guys, the addition of the A plus B, which means the addition of the smaller vectors, to be greater than or equal to the third vector, the larger vector. And if so, surely we can make a enclosed figure. If not, that means if the addition is even lesser than the largest vector there, we won't be able to construct a complete polygon or complete triangle, which means it will be having a resultant, right? So let's check with we'll start with the last one, right? Fifth one, we'll see with the fifth one. We're gonna have the 3 vectors to be equal, so it's kind of like equal, right? And if you add them, it's going to be 10, and 10 will be greater than the 5. So which means surely we can construct a closed polygon, right? Then after closed polygon, so resultant 0. Resultant equals 0. And see the next one, fourth one. Lowest vectors are going to be 10 plus 10, which is 20, and that is equal, right? If it is greater than or equal, then we can make the resultant to be 0. You see the next one, 8, 10, 4. So 8 plus 4 is going to be 12, which is greater than 10. Again, we can make it to be a close figure. Then 5 plus 5, that is 10, also greater than 8. And that is like that. And you see the first one. And that is going to be 5 plus 10, 15. And that will be lesser than, not lesser than or equal, it's lesser than the larger vector there. So we won't be able to construct a complete triangle out of them. There will be a fourth side, and which gives the result. So we'll try write this theory. This is the addition of smaller vectors, the addition of smallest 2 vectors given. Right? That has to be. Okay, so how about the 16th question, guys, on the page 2? And that's the last question we're going to try. Page 2, question 16. Page 2, question 16. Page 2 is not there. Page 2. No, right? Okay. That's the last question we are going to try. And it's asking find the resultant. And you're gonna see there it is being arranged, it is being drawn in a certain Cartesian plane with the proper scale. But some of those vectors are inclined. So whenever you see inclined vectors, yep, you should resolve, right? And add the components. Or maybe you can construct a polygon out of these vectors given with exactly kind of drawing it in a graph sheet, right? That also you can do, or else we'll see it like this. So you're gonna see a vector downwards, that's the first vector you're gonna see at the very top, and it is kind of inclined like this, having I'm just drawing, right, having two squares here, and this is given as 6, and this is given as I think it's got shifted with the scale, right, guys? We'll just correct it. uh, each square will be representing 1, so the 2 should come to the second. යට තියෙන ඉඳන් යට ඉඳන් දෙවෙනි එකට තමයි second එක කියලා එනවා. Each square represent 1. We'll just make the axis to be correct. So it has to be 2, 4, 6. 2 and 4 should be shifted a little bit down. And similarly for the y-axis, right? It is also 2. Then the 4 has to be shifted. 6 and 8 and 10. Sorry about that, right? So you're gonna see there, here it is 6 and here it is 4. Right? I'm just considering about the very first vector at the very top, right? Right. So either way, we have to resolve it now to find the component. Here to resolve, we haven't given an angle there, right? But instead, we know by resolving, we can take the x component to be aligned into this direction of this vector, and the y component supposed to be aligned downwards up to here, so that it can make this triangle, and this is the vector, right? And even though we haven't given the angles and just the vector has been drawn, we can see there the x component of this one will be just 2 squares, so you can take it to be 2. Here you can see that to be 2 squares, right? Horizontally. And vertically how much? Vertically also we're going to have 2 squares, which represents the horizontal and vertical component of that. Because horizontal component is once you place a shadow here, like a torch here, the distance that the shadow will be falling. So here it will be like to this direction, to this distance, right? So it's going to be 2 squares. If I place the torch from here, the shadow will be falling from another 2 squares. This is y. Similarly, you can see the vector that is below. මේක බලන්න පුළුවන්. What's going to be the two components? The y component here is going to be this one, huh? It's going to be 2. And the x component here is going to be 1, 2, 3, 4. Yeah, it has to be 4. Likewise, you can find out all the components of each. Now you should find out the other one here also. There's an inclined vector here in this point, right? And the other two vectors are, one is purely vertical, the other one is horizontal, and you can count out how many squares it has to be for the x direction, the total squares, and how many total squares you're going to get for the y direction, maybe upwards, and you can represent them once again, and yet you can find out the result. Got it? Shall we now? Find all the squares for the x direction and all the squares for the y direction, and find the result. How many total squares for the x direction? Here 4 to this side, 2 to the other side, which is 2, and another, and 4 to this side. We'll add them, right? 4 minus 2 minus 4 plus 3. Isn't it? Yeah. There's going to be 1 to x direction. And for the y direction, you can count again. Here, I'll start with this one. You can have maybe this one, right? 2 minus 2. And the other one is upwards, it is plus 1. And another 2. like that, then it is 3. So the above it is 3, right? So 1 and 3 is going to be what? Yeah, r is equals to 1 squared plus 3 squared root x squared plus y squared root, right? And that is root 10, 3.14. So you take it. Okay, great. So with that, we could kind of like finish this lesson. Unit 1 actually, the measurements, right? So you can see in the 23rd question, if you are wondering what that term is, 23rd question in the page 3, coplanar forces, particle in equilibrium. Equilibrium means the resultant has to be 0, right? Just put there r equals 0. From whatever the forces, the resultant has to be 0. The object is in equilibrium, like here, maybe that water bottle, right? Or maybe this camera bag right here. It is at rest. If there's a resultant force, it should be moving to a certain direction, right? If it is not, it is in equilibrium, so the resultant has to be 0. Coplanar means all the forces are acting on the same plane, which means like this. Let's say these are the forces. Let's say one force is acting to this direction, the other force is to the other side, and if the third force is acting to this direction, they are not said to be coplanar, because these two forces are on the same plane, which is the plane of the board, but the third force is coming towards you out of the plane of this board, right? If it is like this, so here it is not coplanar, means the third force also acting like that. All the forces are on the same plane, coplanar, right? That's a technical term we can use. Don't worry about it, right? Don't get fear about it. Just forces, right? Okay. So yeah, with that we can finish out the entire lesson, the measurements. And as always, there will be a cover story. Do you know about this guy? I think once I asked from you. No. Uh, so this is from the Despicable Me cartoon, the first one. I think you know this guy here. This is Gru, and this is the Edith. This is Margot. I forgot the name about this one. Agnes or something like that, right? So these are the minions. There's a separate story for them, right? They also kind of said to be evolved from the very prehistoric ages, right? Like the fish are turning into amphibians and so on, right? There's a cartoon going on with the minions, right? And in the first cartoon, we're gonna see this guy, which is the actual name is the Victor Parkinson, not Park Perkins, right? Perkins, Victor Perkins, and he's saying that he's have like a nickname to be the Vector, right? I'm just saying this one, not for the cartoon. I mean, not to introduce in the characters, but why we need to learn about the vectors, the lesson, right? You might be wondering, okay, so is this just being used in the kind of like in the board and doing some questions? Well, it's not actually how it works, right? We are kind of did here very primitive things about the vectors, but when it comes to animating these cartoons and all, we should like, let's say this guy here may be moving to any direction, which means we should animate when we are like making the cartoons, right? Animating the cartoons, we should mention their forces or the direction they move and how fast and so on, right? All these are being generated in the 3D space, three-dimensional space, x, y, and z, right? Three planes. And if something moves, it's a matter of changing the coordinates in that plane. You're gonna see here this bag right here. is on this table. So it has a certain position with respect to the entire classroom, right? From this wall, there's a certain distance. From this wall, there's a certain distance to this. And maybe from the roof or maybe from any other side, there's a certain exact position, right? So if it is moved from here to there, from here to here, which means it has been changing the coordinates in that 3D space, right? And to do this one, we need to play with the vectors that are acting to the three perpendicular directions. And we can define the velocity of a certain object or maybe the displacement. In all those cases, we should mention the magnitude and also the direction, which direction it has to move and how much is the magnitude, likewise, right? So all the cartoons, all the gamings, right? I think you have played the Free Fire, no? Any other mobile game, like at least making cakes out of that, the farm, right? The bird farm or whatever, right? Making eggs and all, right? And selling them, making cakes and all. So all those mobile games and every gaming platform is dealing with the vectors in the 3D space, right? They kind of lay out different positions to construct an enclosed figure, and in the 3D space, all those are constructed by the like multiplying or doing some mathematical operations between vectors, right? So yeah, this is a very short lesson that we have just learned for the A levels, but if you go for advanced levels and maybe like go for like IT industry, bio ones can also go, right? I know that few of my friends has done bio, and they one of them has been selected for the medical faculty also, and they went to the software engineering at University of Moratua, right? So they are doing very well. Of course, the girls are also, right? So likewise, if you're just interested in the IT fields, these are going to be again used, right? Not in like resolving stuffs, but in a much advanced way. Okay, so with that being said, we can finish up this lesson vectors and also the entire first unit, the measurements. Next week, we're gonna be starting uh, the next lesson, the unit 2, mechanics, starting with the motion. And you're gonna get a new tune as well. I think up to now you have just 2 tunes. Make sure you just finish up every question in the tune before you leave it out. Right? Otherwise, things going to stack up, right? With a whole lot of unfinished questions. Okay, thank you for joining the class today, and we're gonna finish up a little bit earlier since we can't start the new lesson. You are kind of not in the class. So it's 12:05. Thank you again. See you very soon.